Like we promised, if I get all you guys in the back to come on in, we'll get started here. By the way, if anyone's interested, we're also simulcasting upstairs on the 8th floor in our big meeting room. They just told me I have to stand in between these two screens to make sure that I can simulcast this boring professor-looking outfit I got on today. But thank you guys for coming back. Hopefully you found something to do in Austin last night. I know it's a boring place. Today's going to be pretty cool. I'm pretty excited about our panelists. We've got some keynote speakers and some more breakouts going on. If you didn't hear yesterday, on behalf of General Rainey and Dr. Purley, who's the director of AAL, I'm Tony Williams, and I run the Corporate Ventures and Technology Due Diligence Group here at AAL for Army Futures Command. So without further ado, I understand that the first panel moderator is going to be Sean Anderson from DIU, which we're happy to have. He's got a panel of CEOs and founders that I'll let him introduce, and maybe they can tell a little about what they do first before you guys get into it. And then we've got a pretty good keynote coming up, a couple of other founders in the robotics space, and they're going to talk about how they built their company, how they work with the government, some of their design philosophies, and some of their ideas on bringing capabilities to market. So, and then the final panel will be hosted by David Bonfili from Acme, and then we've got, again, some more founders on the company side of what we do. Also talk a little bit later about our next big event, or at least Capital Factory's next big event is the Fed Supernova, which I think you guys might be interested in because it'll give you more of a chance to kind of dive into all defense innovation rather than just AFC and AAL. So with that, John, I'll let you have it.
I think we're on. Awesome, yeah. Thank you. Sure. My name's Sean Anderson. I'm from the Defense Innovation Unit. I've been really lucky that Army Applications Lab has given me some time today to talk to these gentlemen. You guys can come on up. I'll introduce you as you get on up here. So if you're not familiar with the Defense Innovation Unit, slightly different than Army Applications Lab, but kind of working in the same space. Defense Innovation Unit is a joint organization rather than an Army-specific one like Army Applications Lab is. We have slightly different authorities and operate slightly differently to try to scale commercial technology and bring new capabilities to the warfighter. Other than that, we've kind of grown up a little bit recently, back to a direct report position to the Secretary of Defense. We have 6 portfolios covering everything from AI and autonomy down into energy and the space. With me today, I've got John Goodson. He's the CEO and co-founder of DarkHive. I've got Jeffrey McChesney, and he is the CEO and founder of Target Arm, and I think many other companies, and you can tell them about that. And then I've got Adam Muhammad, who is the CTO and co-founder or founder of Asalon. So if you could really quickly, our subject today is about UxS teaming. It's a very broad topic. We're going to talk primarily about some of the pragmatic things that we've learned and experienced from our different angles, particularly in the recharging space, the launch and recovery space, which each of these gentlemen have some specialty in, as well as the kind of necessary things that we've seen either doing small swarming projects, whether it's just air vehicles or air and ground vehicles, and the things that we've learned along the way. So if I could, really quickly, John, do you mind telling me a little bit about what DarkHive does, what DarkHive is, and how you're working with the DoD right now, and your experiences with UxS teaming?
Yeah, absolutely. Am I coming through okay? Good? All right. Yeah, really happy to be here today. Over with DarkHive, we're really kind of focused on developing not only autonomous drones, but those that are really low cost and ultimately disposable in field. To date, we've been doing a majority of our work with the Air Force. Recently got turned on for a Phase 3 IDIQ with AFWERX Autonomy Prime. So looking to do, yeah, I think you put it very well, tackling some of these hard problems that I know Defense Innovation Unit, DARPA under the Offset Program, AI for Small Unit Maneuver. All of these programs are really heavily focused on this user experience aspect of what it means to have collaborative human-machine teaming, and at least for our part, trying to produce platforms that can really get us to the point where these things can provide value, but from the operator perspective, it is a capability that delivers information that can be understood and drive the kind of decide and act cycle, honestly, to where we ultimately, if we lose these things in large numbers in field, as long as they are continuously providing that insight and driving that decision-making cycle, that through recharging and continuous drone operations, that capability is continuously accessible, and so that's a lot of what we're focused on.
Awesome.
Okay.
Go for it, Jeff.
I'm good and loud?
Yeah.
Hello, everybody. I'm Jeff McChesney. I'm the CEO and founder, as Sean said, of Target Arm. And we have a device that enables you to launch and recover drones, both rotary and fixed-wing drones, autonomously from any moving vehicle. Plane, train, car, ship, spacecraft. It really doesn't matter what it is because we end up coming in horizontally and we come in co-speed. We've been dual use over the last 5 years. Predominant focus has been on package delivery and the ability to actually fill a seam that doesn't exist today, which is to actually deliver drones from a package delivery truck moving up and down the highway, even at highway speeds. Again, we work both with rotary and fixed-wing drones, which opens up a whole panacea of opportunities that no one's ever looked at before. On the DoD side, operational maneuver is a major factor for all the services and in the joint world as well. And the ability to be able to launch those drones, but more importantly, recover them and recharge, refuel, rearm, and future repair while you're on the move and not stopping is going to be a big factor, because who wants to stop and get shot in the process while you're setting up a drone and trying to catch up to the formation that's actually left you behind again, or you're out in front and they catch up to you. So the idea here is that there is a seam while things are moving, which we all want to be doing on the DoD side, that allows you to change your ConOps, to start thinking in a different way. And then on top of that, the idea that we're dealing with every day is we have two robots working in unison. So the two ideas is that our system is called Tular. Tular is working with anybody's drone with a wraparound SDK that allows them to come in and land horizontally or recover horizontally. Those two robots are working independently, autonomously with comms or without comms, with GPS or without GPS, and we've designed it from that way from the beginning. So we're already working with two autonomous drones or two autonomous robots that are working in unison for that uncrewed teaming capability, and you can put a man in the loop or a crew in the loop if you need to. So we're already solving some of those problems on trying to look at what do you do for the forward line of robots, what do you think out front of having a UGV launch a UAV and recover it back and rearm, recharge it, and refuel it, and possibly repair it. Those kinds of things are now starting to become possible, and we're dealing with them on a day-to-day basis.
Awesome. Adam?
Good morning, everyone. Can you hear me? Good? Yeah? Okay, cool. Awesome. Adam Mohammed, CTO, co-founder for Acelon. We focus today commercially, we're dual use on providing perimeter security surveillance, robotic packages. Our twist on this, though, is we're providing it remotely with humans nowhere near the robots actually operating. So the idea of someone pulling out of a rucksack, putting a drone on the deck, or to launch it, or pulling a dog off the back of a truck. We provide infrastructure on top of all that such that they deploy themselves, operate, come back, recharge, refuel, rearm, and then go back out again. And there's no humans interacting with the robot during the entire mission process. We've been doing this for about 4 years commercially, also working with Air Force as well on a variety of development projects. The idea here being fixed facilities today need security assets that can respond to alarms automatically, autonomously, and we do that with these systems. So similar to some of the folks here on the panel, we are automating everything from the mission upload to the launch to the recovery to the battery swap, the maintaining of the equipment, remote diagnostics, all those things that are required to actually let these robots run not once, not twice, but 100 times, 1,000 times without humans actually interacting with the system. The best way robots work today is without humans actually touching them. So.
Awesome.
Thank you, Adam.
Sean, I failed to mention also, just
Yeah.
as part of what you asked for. So we have 2 Air Force contracts we're working right now, SBIR Phase 2s. One is for nuclear munitions convoy protection, quite appropriate on the Army side. They're operating with protecting nukes at 60 miles an hour down the highway. Obviously makes sense for them on the move. And we're also doing a development project to put it on a C-17, to launch UCAVs to and from C-17, and we're working that with McGuire Air Force Base, the former with F.E. Warren.
Thank you. Adam, you had mentioned you've been working with some of the ground systems in combination with the air systems. Can you talk to some of the specific challenges that you run into when teaming those two together?
For sure, yeah. So like one of the unique things is we do air and ground for a lot of these robotic perimeter security packages we offer our customers. And we started with the air assets like most folks do. Great line of sight, great efficiency in terms of getting out to where you need to and getting back and seeing what you need to do. On the ground side, I would say the first issue we ran into initially was comms. Like the fact that we don't have a nice clear line of sight to the nearest radio tower or comms node relay was very apparent. And it candidly took us a little bit to figure out how to make that work in the real world. So adding more powerful comm packages, more agile comm packages that can adapt and degrade gracefully were kind of like the initial things we had to hit. On top of that, aircraft in the sky, real nice big open space, unlikely to hit something else. On the ground, exact opposite. You have vehicles, you have people, you have structures that moved overnight. And those were the things, the unpredictability of the ground was our other major headache, is how do we maneuver around these obstacles and path planning and resiliency to get from point A to point B to do your mission. So from the ground perspective, I would say those are the 2 major things. A pro, I'll say, if I'll jump in here and glob on, is that when a UAS fails, it generally fails catastrophically, right? So either you're flying or you're not, and everything's either destroyed or not. With ground assets, that's not necessarily the case. If it fails, rolls over, falls on the ground, we use quadrupeds today, it can generally get back up again. But if there's no comms, how do you handle that? So it's a different set of problems of you're not necessarily losing the asset, but you're actually able to recover it quickly and resume those missions. So just another thought out there on that. So.
Can you talk, Jeff, about some of the persistence, maintaining a persistent operation, what actual scale of the logistics train behind charging and recharging drones to maintain a constant cap over whatever your mission may be?
Yeah, it's a great concept. The Fort Benning, now Fort Moore, asked us to come down a couple of years ago and help them think through, from the robotics requirements perspective, how do you actually, with an infantry group, with a SMED or MUT, or even RCV now, how do you actually launch and recover out in front of you or around you and do that for 24/7? My former background is F-15 air-to-air capabilities. I'm a pilot, and that's exactly what we used to do, combat air patrol. So this is combat air patrol with a ground unit. Conceptually, it's the same concept. And what you have to do is you have to worry about cycling, how long you have persistence in the air, and that is a major problem on especially battery-operated quadcopters, is how much time you have, and then you've got to cycle them back. And so one of the major aspects of trying to maintain I'm going to use the term cap just to make it everybody understands it. So using a cap out in front of an infantry group that's moving, you end up losing about half of your time even to go back and land back in and recharge. And so in our capability, we actually have the ability to universally recharge. Adam's capability is you do the battery swap out, which you can do as well. So those kinds of technologies are available to you, but there's this cycle time of being on station and coming back that is very, very difficult. And the extension of time is the major factor. So this time component, if you've got 30 minutes of battery time and you got to get five minutes out, you're probably only going to get about 15 minutes on station to cycle out, and then you have to have the next one coming back in. So you increase the numbers, in that case, logistically now to your question, you increase the numbers of modular payloads that you have on board these robotic vehicles that you now have to actually coordinate and cycle. The problem there logistically is the comlink. Now it is a coordination, which is which ones go up, which ones come back, and how you cycle that. It's not a hard problem. It's a hard logistical problem. And now if you've got a moving formation, it actually has to have that secure comm capability to do that.
Awesome. So John, you and I chatted yesterday about some cybersecurity lessons learned in this space, and obviously you just kind of mentioned it as well. One of the things that we see a lot is in the DoD space is not a lot of opportunity to update a system, right? A system will be out in the wild, and once it's out in the wild, it's essentially a fixed piece of hardware. I liken it to essentially trying to buy a new iPhone every time you want a new app, right? Instead of actually being able to push an update, whether it's a hardware update or even software updates being the most simple, trying to get an update into the field and how that deals with your enemy's kind of OODA loop and your own. Can you talk to that and share your anecdote about kind of Starlink systems?
Yeah, absolutely. I think anyone who's kind of played in DoD and trying to get systems accredited has lived through this nightmare personally of going through your STIG compliance for all your hardware and your software, and anywhere between 6 to 18 months for getting even a piece of software accredited, let alone a piece of hardware. And so anyone, conversely, who's worked in the commercial side has, this does not compute, right? If I want to do software continuous delivery, update my app, update, security patch on, an edge device, you just do it, right? Provided that you have connectivity. So, thing that Sean and I talked about that I think a lot of us probably saw about this time last year, and I know there's a lot of debate about, the particular details of this incident with Starlink in Ukraine, but let's just go with the media-approved story, which is that essentially, area of Ukraine gets liberated. Ukrainian forces move in. This is post Starlink offering them all the terminals that they were able to use to reestablish connectivity after a lot of the telecom infrastructure got destroyed, right? And one of the things that they encountered and that Russian state media validated was that they had a new SATCOM EW system in field that was essentially directly targeting SATCOM links. And then this miraculous thing, at least according to Starlink and then according to OSD happens, right? Where a security patch gets pushed over the air to all the Starlink terminals that essentially change modulation type, band that it was operating in, band shifted it, new frequency hot pattern, whatever it was, but software patch fixes the issue with a particular Russian EW system interfering with SATCOM. So obviously, response to that was incredible, right? It was across the DoD service components, everybody from the Air Force to the Army was saying, this is incredible. I wish we could do this, not just for our comm systems, but really for everything that we have in field. This is where we need to get. So doing that, understandably, within a government-accredited framework is incredibly difficult to do, right? The best people in the industry that are doing it, really come out of, the continuous ATO and RMF compliance frameworks under Kessel Run, the Platform One teams, Cloud One teams. So there's a path forward in doing this, and we really need to be able to do it to bring it all the way back around to human-machine teams, because exactly as we're seeing in Ukraine today, tactics at the strategic level, tactical level are changing all the time. Ukrainian forces do one thing, Russia counters, right? Doesn't matter if it's EW, doesn't matter if it's how unmanned systems are being used to do ATR in field. These things are constantly in flux. And so we need the ability in an environment where these systems are expected to operate autonomously, very much like I think Jeff mentioned earlier, where comlink may not be a guarantee. You might not have the ability to go out and remotely see to this with your GCS or, be able to pull any information back. GPS may be gone. How do these things behave in field, and how can we dynamically change the capabilities of them with software? Not strictly the way we think of modularly updating systems with hardware today, new sensor package, these things. We need to be able to change the capabilities of those edge platforms strictly with software push, to be able to do the same things that Starlink and industry already know you can do when you aren't hamstrung by a lot of the restrictions that the DoD understandably puts in place for their systems. So hopefully I answered
No,
that.
I think you nailed it. And I think we've seen this kind of time and time again from whether it's DARPA's work in Offset or other projects like it, the AI or artificial intelligence for small unit maneuver projects, all these multi-agent, many vehicle control projects require kind of that tactical flexibility and communication amongst agents. And so in order for your tactics to update, you're going to have to break that calm cybersecurity cycle where you can't possibly push an update down to all your agents. And being able to do that in the field going to become increasingly important.
So Sean, if I could
Go
add
for
to
it.
that, yesterday I was wargaming with the Air Force, unclassified, and one of the things that came up was OFPs in the Air Force, flight programs, trying to update them. And they had planned on trying to change the behaviors, was what we're really getting down to on the robotics side. You want to be able to change the behaviors of these robots to do what you want. You've learned something today, and you want to push it out to the fleet. Not a trivial task. And you turn around and you say, okay, I have a new behavior, and they planned a 6-month cycle. That's the current environment for a 6-month cycle. They can't make it. They're at a 1-year cycle. And it's starting off with 2 months of initial coordination, completely admin. Nobody in the field even involved, with 2 months on the back end involved, and then the engineering in between on the center. That, if we get back to an OODA loop from Colonel Boyd, right, you take a look at this, you go like, I can't, I've already observed, and I've already oriented, and I've decided it's the act part that's taking me forever to actually execute on these things. That loop needs to probably be within 24 hours when we start talking about the ability to have all of your robots react to how you want them to be doing. We're not even close to that. That's a huge issue to change those behaviors, and we need to figure out a way to do that. And it's a risk profile, right? It's how much cybersecurity risk you want to induce and how much behavioral bugs you want to induce in that process and how much testing you want to do. But in a time of war, you have to be able to move that very, very fast. And we are nowhere near capable of what the robots can actually adapt to right on the spot. So that communication pipe is not only can we talk to them, can we talk to all of them, can we push lots of data through there, can we actually do that back end and actually decide what we want to do earlier?
I would chime in and just respond. I mean, I think you're absolutely spot on in terms of the cycle and lead time. What I would argue, though, honestly, is that we can do this in 24 hours. Companies do it all the time. ML ops companies do this all the time. Your model breaks on day 3, you retrain it, it's redeployed. We can do it outside of DoD environments. So the 24-hour cycle is the target 100%. Again, just back to the Starlink argument, right? There's a problem with there's a problem with the terminals operating in field. What's that problem? Can we do a quick observation, look at a spec A? I think I know what we need to do, and we fix it. So it's not necessarily a problem industry side. Like, there's a way to do this. It's done continuously, right? Even from a behavior side, especially if you look at a lot of the modeling and sim environments that are out there. Whether you take the pure commercial versions where we do all of the cycles and whatnot, utilizing Gazebo or utilizing the Coliseum if you go into the DoD frameworks. We can do this. We can train. We can validate. We can push. But how do we do it in an accredited way? And again, we've seen this with web-based applications under Kessel Run. You can do it. We just have to get all of the policy and frameworks in place and the approvals, I think to your point, where you have to take on a little bit of risk in that process. And figuring that out and figuring out a way to standardize it is really the barrier, not the ability to build the technology.
And it's okay to get it wrong. I mean, even if you push it and get it wrong, you can fix it in 24 hours. So the idea here is that that risk level is also compressed by time. So even if you've made a big mistake, oh man, that's like the worst thing we ever pushed, we can actually update it again and keep going forward.
I was going to add to it.
Adam.
I was going to add to it, like, we do this today. I operate these robots today, every day, 24/7, 365. It's not a, theoretical in a lab. This is something we do. We have updates we push. The severity will drive it. If it's a critical update, we'll update the entire fleet in a 24-hour period. If it's, a medium risk, we'll go in and update 2 robots. Hey, does the fix work? To everyone here's point, it's risk management at the end of the day, and how do we get the fix in the field? And I would challenge and say, I don't think software is not the only thing you can do that to. You can do that with hardware as well. With the advances in terms of logistics, we can get a new hardware fix for a critical problem out there in days or weeks, not months or years. And in fact, to the point, our average development cycle for hardware is 6 to 9 months, and we're doing large, sequential updates. Anything less than that, and you're going to be obsolete when it comes to robotics.
Can I change topics a little bit?
Sure.
I don't want to spend too much time on just cybersecurity stuff and updating, but I think there's some other pragmatic things that you've kind of discovered, particularly when it comes to the bandwidth problem, right? It doesn't really matter what the military's limitations maybe are on bandwidth. There are physical limitations on bandwidth in a lot of these environments that simply aren't going to be overcome overnight. And so what can you do when you're designing a system that's supposed to operate as part of one of these teams, particularly in a disconnected sense, and when you're very concerned about bandwidth or burst comms?
No, great question. I'll add my 2 cents, and I think we got people that have solved some very, very hard problems on the communication side, particularly, some of the stuff Jeff was talking about with recovering these things in comms denied environment. I think he's got a lot of really important stuff to say there. But just in general terms, if we are operating in what I'm certainly used to when I still ran around and did interesting things in the field, with hub and spoke model for how we are interacting with these devices, one or more, and where C2 is remote from device, the command and control authority is remote from device, and that device independently with no remote command and control is incapable of performing tasks, incapable of generating outcomes. That is not the environment that we're seeing in Ukraine. It's not the environment that we could expect to see in other parts of the world in a conflict with another peer adversary. So when we have hub and spoke model for providing a lot of these autonomous human-machine teaming capability, my perception from what I've observed and read and heard from the front lines in Ukraine is that those systems that function that way will not survive in those environments. There needs to be availability, compute resource made available at the edge to be able to support a lot of these autonomous capabilities that is not reliant on RF-based communications, because you cannot rely, I don't care how LPI, LPD the signal is and all of these things, because I'm sure like a lot of people that read a lot of the same stuff, talk to probably a lot of the same people, seen plenty of ordnance called down on top of LPI, LPD radios, right? Can't be detected, can't be pulled out of the noise floor. Artillery just got called in on it, so I don't know what to tell you. So we really need to be thinking, I think, collectively as a community about what happens when your really exquisite system that you were promised absolutely would not be detectable in field and would provide you that persistent comms link between these devices to enable these behaviors. What happens when it's gone? There is no comms link, and how do you enable those devices to still go out there and generate outcomes? And that's, again, high-level generalisms. I think we got some real rubber meets the road next to me. So,
We'll see.
Get after it, yeah.
Yeah. So the assured comms, right? We're focused in on the Ukraine, and we're focused in on what we used to do with the Iron Curtain and looking at the Soviet Union. Those have all led us through history, right, to where we are today. But we have a near peer on the other side of the Pacific, and it is a tremendously difficult problem with the tyranny of distance, the tyranny of time, logistics, everything that's associated with our near peer that we're looking at in China. And all of the problems that we're talking about are like 10 times harder out there. And the assured comms are critical. We've just talked about you have to be able to do these updates. You have to be able to communicate with these robots. You have to change their behaviors. You have to give them missions, right? You have to tell them what the mission is and change the missions. And that level of autonomy that you give them is also based upon your ability to communicate with them. If they're severed, do you let them keep going, or do you have to, or do they have a stop? I don't know what I'm doing. I can't kill. And where's the man on the loop or in the loop in that case? Those are all very, very difficult problems. But the Chinese, in particular, are focused in on their number one task is to take down our communications. That's the very first thing that they're going to be going after, and there'll be offensive communications denial they're going to be going after. And so we're up against somebody we're trying to do operational maneuver to get into that space and to operate into the Pacific. They're trying to deny our ability to actually coordinate and communicate at the same time. This is not a trivial task, and as John's just talked about, we've got people who are working on this, and in the fog of war and in the enemy not doing what you actually want them to be doing, we are going to have broken communications, and we have to have that graceful degradation built in right now. That we're going to lose comms, we're going to gain comms. We're going to lose comms, we're going to gain comms, and then how much autonomy do we give each of those robots at the edge, and what do they have to have available for compute on board?
Awesome. I'll take a slightly different tack from where we're going.
Yeah.
Let's talk about permissive mass. Like, we're in a permissive environment. Let's put 1,000 drones up. how do you support the data links for that? That's a huge burden today, even in a permissive environment, let alone in a war zone.
Yeah.
So there's like everyone's saying, autonomy, ability to get back to your home or continue on your mission is paramount. And the other thing I'd like to talk to you about is that's a hard problem by itself. There's also just not even malicious, but ambient in the environment. Sometimes you land somewhere and all of a sudden anything across this spectrum is no longer available to you, not because the Chinese or the Russians have jammed it, it's just because the environment's not helpful. And how are you adapting to that? That's your first step zero problem before we can even tackle these harder problems that you guys are talking about. Building that autonomy, building that resiliency, that graceful degradation, I like that term a lot because that's what it has to be, starts there and only gets harder as we go down this path. So we personally have faced this problem where we show up a site, did a site survey, our spectrum's clean. Show up 2 weeks later, the entire band's gone. And it's we don't know why. We look through, the customer says, no, we don't know. And we're great, so we have to adapt. And I think that is step zero is being able to build the flexibility into the platforms, not just autonomy, but hardware flexibility, software flexibility to allow for you to operate in these environments. And as we start there, fail fast there, and as we get into these harder environments, these non-permissive, competitive, jammed environments, it only gets harder. But I think we start there first.
So I think two of you mentioned compute on board systems, basically, compute available on systems. And I know we've talked about it in the past as well, Adam. When that comes up, how can you communicate to other companies or potentially model vendors or somebody who's looking to use the compute on board? How can you effectively communicate about specs or standards? We had a very passionate conversation yesterday about standards and C2 links, but how can you actually establish standards or specs for inserting a model into something that has a variable amount of compute available, all sorts of different sensor feeds, and trying to improve that? I'll go back to you, Adam.
Yeah, so from our perspective, that's a huge thing. It's I'm a firm believer that we can't solve all the problems by ourselves. We're going to have to partner with folks, and there's going to be a lot of money and dollars spent on the software load. That's going to be probably the biggest thing that's going to come out of this for robotics in general is the software loads, the ML packages, the AI packages, the autonomy packages. They're going to be packages. They're not going to be tied to a platform. And to your point, that means you have to have compute on board. How much compute? What kind of compute? What makes sense for the mission at hand, for the platform we have? If we have a group 3, UAS, let's put a Super Cray or something on board. But if we have a group 1 UAS that weighs 5 pounds, what can you get away with? And then communicating those standards of saying, hey, for a group 1, we're going to have this up to 20 pounds. You're going to have this kind of compute capability, and that's it. And acknowledging that is going to be the fact, because then we can actually optimize the ML software packages to meet what's available to you. And I think establishing that sooner than later will help not only the software folks, but also the hardware providers, the platform providers, because we have to swap that in. That's hard on aircraft. That's hard on ground vehicles. And those are things that we should really be establishing now for the next 5, 10 years, because that's going to drive what we do as an industry, and we can actually go hand in hand. Instead of a fight of saying, I made this elegant, ML package, but I need 3 supercomputers and 3 U's of compute to run it, it'll never get on platform. So establishing those standards now, I think, is critical if we want to make something that works for the warfighter. So.
Go for it.
Yeah, and I think coming at it from, that was very, very well put. I mean, coming at it from just a different angle and having navigated the world of standards for a while now, I got out of uniform in 2016 and had a million different standards thrown at me. I mean, especially in the realm of electronic warfare and JICD and things like this. And what I've found pretty consistently, whether it was a big communications and C2 standard like that, or even an integration target application like the TAC family of systems, that if you are going to, whether it is an industry or whether it is government is going to define a standard, if you're going to go that route and you want industry to rally around a standard, then it needs to be discoverable, understandable, and well documented so that people can easily adapt their technology to that standard. This is something that in many cases government does sometimes a good job of notifying everyone that there's a new standard that should be adhered to if you want to play ball in some joint warfighting environment. But what sometimes is missed is, okay, great, I'm a company that developed this amazing, ML model, and I would love to play in this environment. Where do I go for this? Oh, you really need to get your CAT card first. Okay, so I need a contract or someone I can sub. I guess I can go get a CAT card. Okay, I got my CAT card. All right, go find the documentation. Okay, I guess I'll go find the documentation. Who do I go to for help? Talk to this guy. But he's actually out of the country for the next 6 months. So I don't know, post to the forum. Post to the forum. Nobody responds to the forum. And so I'm making a joke about it, but you guys get this, right? And this is where we run into consistently. And this is the barrier that gets thrown up between industry and government collaboration when a standard is created. There needs to be rapid onboarding and support if there's a standard is going to created so that industry and government partners alike, research labs that want to participate in these environments, can very quickly get access, understand, and begin working within that framework. The groups that do the best in this and the lessons we take from the open source community, right? The open source community projects that have the largest core groups supporting and answering questions in forums and responding, these are the ones that take off the quickest because developers can easily understand how to play with them. And so I would just come at it from just a slightly different perspective that, yeah, if you're going to open up compute resources on board or mandate that for these platforms, okay, great, I'm industry, I want to play, what do I do? Crickets. That doesn't work. That doesn't get people rallying around a standard. Openness and support is what gets people rallying around a standard.
Couldn't agree more. Jeff, you had some really interesting ideas about standards and standard development, because right now there really isn't a lot of standards in the C2 space for small robotics.
Yeah,
do you mind kind of extrapolating on that?
Sure. I mean, one of the problems that we have right now is that I'm looking at this through the prism of a commercial company, right, into the DoD, much as John has just mentioned as well. The idea here is you're looking at it and you're going, okay, where do I spend my time, energy, and money as a company? And when I get to that equation, I go like the barriers to entry to work with DoD and the standards that we were just talking about are like, okay, I can go this direction and in 2 weeks to have what I want, and I can go this direction, and a year from now, being a former Air Force guy and understanding how DoD talks, right, and how it's set up and how it's organized, I still have problems going down that 1 year path because it's an ROI question for me at the same time as a standards type question. The standards that I look at, and we've all just kind of alluded to it, is that DoD isn't driving this train anymore. 40 years ago, DoD drove the train on the R&D side. We said we got a standard, and the whole world rallied around it. It's the other way around now. The commercial world is saying we're aggregating around a standard. Let's just say automotive, okay? On the automotive side, working on autonomous vehicles. I own one, so I get to watch it every day and go like, holy shit, it's better than we're doing in a lot of cases, and in some cases not. But the idea here is that they're creating standards very rapidly with a large group of people, open and collaborative, and then we come along and say, okay, here's a DoD standard that might be close, but it's over here, and I can't understand, it's hard to get to, and I don't even have a contract associated with it, and I have to develop towards it. That is very, very difficult for us to be thinking about as a company wanting to get into that space. And so what we all probably are thinking about, and you guys can speak for your own companies, is that we get the contract and then fit the standard when it comes with it and figure out how you're going to actually do it, not the other way around. I don't go to the standard and then get the contract. And it's very difficult in the robotics arena because most of the work is outside of DoD.
I'll just tack on one thing. No, that was great, man. And something that you mentioned made me think about this thing that I've run into with standards. Oftentimes, one of the reasons a standard gets created certainly is to get everybody on the same sheet of music, but also in some cases it's to help the DoD prevent vendor lock for a particular performer who defines a standard and then is just so big that they just dominate everything. And so DoD comes in, competes for who is going to define this standard, who is going to design it, and specifies very clearly this will be a government-managed standard. The government will define all of it, and when it is done, the government will own it. They own this standard. They own this specification. Who wins the contract? The big performer who already owned all of the data links and standards. And again, accessibility and openness. This is fine as long as it's open, as long as you do it in a way that small industry performers can come up, understand, onboard, and begin to develop against that standard, I think, as you were saying. But if what happens, as it typically does, is that that performer operating at the direction of the DoD says, cool, okay, so we're going to define this standard, you're going to own it, it's going to be your standard. So I think the first thing is that as we define the standard, we really need to make sure that this is up on IL6, classified network environment, make sure that anybody that needs to get access to it has a SIPR token. That sound good? And they're like, yeah, it sounds great. It's like, okay, small industry performer comes up, cool, I never worked with the DoD before, sounds really cool, what do I need to do? Okay, so first you're going to need to get an FCL in place, you need to get your DD-254 set up. Do you have a contract vehicle? Like, you know?
Got a SIPR phase 1.
And they go, I don't even have a cage code,
yeah,
right? That's the way they start.
I got a SIPR phase 1, 3 months, 75K, I'm super excited, right? And so anyway, sorry, that just really keyed it up for me.
So I'm going to jump in here because, like, just to tack onto that.
Yeah.
So we got this magic standard. It's IL6, stuck behind a wall. And how often are we updating this standard? Because that technology is obsolete in 24 months. And now we have to do this process all over again if it is done at all.
Can you send home for me? So I want to get back to the teaming aspect of the standard, though. Like, the reason why we bring up standards like this is because in many ways they can be really fundamental to making sure that when I have two heterogeneous assets, it doesn't matter if it's a ground vehicle, an air vehicle, or different modes, but they need to be able to communicate about the world in the same ways, but you also need to build agents that can communicate with them, that I can communicate with a bunch of different come-as-you-are aircraft or ground vehicles or sea vehicles. What about a standard actually makes that easier for you guys as you develop?
You want to go?
Accessibility,
Yeah,
accessibility and documentation around that standard. My ability, and I think DIU has done a really great job of trying to invest in not just defining standards, but also in investing in hardware companies that produce modular assets that can be utilized to adhere to those standards, not just from how I'm moving data, but also like, oh, cool, I can incorporate this comms module or this compute module into my hardware in order to ensure that I can plug into this standard. So that's my first thought on it.
It's like really focusing on what the data you actually need. I think that's a really big thing. We've gotten spoiled with this one-to-one operation of like, if it's a ground asset, air asset, pick a vehicle type, and you're like, I get everything I ever need. Do you actually need that data? Especially for when we're going to scale. You need maybe a video feed sometimes. You want to know what they're targeting, what they're looking at, what their mission objectives are, but like getting that common like factor really helps, especially across heterogeneous vehicles. So I do air, we do ground. They have two very different protocols, but we pull a handful of parameters at all times from them, and they are consistent. And I suspect they're going to be consistent across all domain vehicles. And it's understanding that like air assets have very different needs than a ground asset, than a sea asset, but it breaks down to where am I going, where am I at, and what is my mission objective, and any other pertinent, payload capabilities on top of that is really what drives those vehicles. So standards that like focus on what do you actually need to pull and not everything under the sun, I think is critical here.
One of the things I might mention is that, and I know we're trying to do this as a DoD, and I think being former Air Force, I can still consider myself DoD in a lot of respects. That it's almost like we want to make sure that the DoD is helping those open standards. In other words, instead of trying to drive a standard that fits DoD, drive a DoD input to the standards that are already out there in the commercial world. That, I think, is the key to this solution, because we have millions of people, at least hundreds of thousands of people programming in some of these standards, that if you're trying to create your own over here with a couple of engineers that are rotating out every 2 years on a PCS or TDYs, and they're over in some other part of the world, and they're coming back, and things are just much more difficult to operate on the DoD side versus those inputs to say, when we all build this universal standard for X, let's get the DoD inputs in there that say, we want to have a hook over here that says we can put encryption in here because we really need this kind of encryption. And so we build the open source standards with DoD's inputs, I think, is probably the way we're going to have to go in the future. And that helps us with that quick evolution process and not this 2-year cycle and becoming out of date.
I think specifically there's, and I think that's my golden nugget for today, but there's a specific need to get some of the unique insights that people like the Army Applications Lab or the various, whether it's AFRL, the various labs actually experience these things that maybe a team building an open standard didn't think of, right? Like that one little necessary nugget of wisdom that they have that said, hey, look, I was doing this on something that was supersonic the other day, and you're going to want this. And that's what all that would save a ton of work down the road. I have two more things I want to get to before we do questions here in about 5 minutes. Jeff, in your specific use case for Target Arm and what you kind of described, it sounds to me like there's a fairly challenging implementation of two basically local frames having to meet in one world frame when it comes to the two different systems. Can you talk through some of the challenges there? Because I think those are significant, and they extrapolate across systems, particularly in GPS-denied situations.
Yeah. It's not a trivial problem. We spent a lot of time working on it. Our actual device that we have for TULAR is it's mechanical, electrical. It's pretty simple engineering. The hard part is the software piece in the precision location. So the idea here is that we've actually built a sensor fusion engine. And so when we talk about in a GPS-denied, COM-denied environment, you're going to need multi-sensor capabilities on each of these robots that you have operating on the ground or in the air, or even underwater for that matter, or in space. So the idea here is that you're taking, as Sean has just talked about, you're taking a reference frame of one robot and a reference frame of another robot, and then you're moving them through space at the same time and then bringing them together. That is a very, very difficult localization problem. So some of you are involved in localizations and you've got sensors, now have it moving, and the reference frame now is built upon the two of you moving through space. It's almost like Einstein talking about relativity, right? So it's a relative space that you're going through. And then the ability to actually come in horizontally and get to a very, very tight location. In our case, we're looking at 1 millimeter accuracy is our design goal, and we're at it right now, of 1 millimeter accuracy of holding position while you're moving through space. That is something that you can't get when you say, I want to hit land, and Adam and I were just talking about it before this. You can't hit land in your flight controller that you buy at from one of the vendors that are out there today, because they're all coming in vertically. And so this idea to come in horizontally, which opens up the ability to be able to do this on the move at speed. Now, you can do it at 5 miles an hour vertically, but you can't do it at 50 miles an hour vertically. That is a very, very hard problem that you have to have a sensor fusion engine, which leads you into how are we building sensor fusion engines, right? And how does DoD approach sensor fusion on a small UAS or a large UGV? And say, how do we do those, and what do we have available to us, and how do we take those sensors up and down that are available to you? So sometimes you're in the day and you can use computer vision, but you're at night and you need to go IR or RF or other sensors that are available to you. So how you bring those together in that graceful degradation of those sensors, you have to have a sensor fusion engine. And in our case, nobody had one that we needed to do, so we built our own. You don't want us to build our own. Right? You want to have a sensor fusion engine that is compatible with all of these vehicles and all of these capabilities that can move up and down the spectrum of very small and light and also very, very heavy and complex and 50 sensors on board.
Changing the subject, but kind of similar. One of the things we've seen repeatedly is multiple assets distributed, operating even amongst themselves with some sort of coordination, but observing essentially the same target in the world and not being able to basically communicate about it effectively, especially when each of those assets is trying to reduce that target, not propagate more and more video across the network, but really reduce that target into metadata, right, about it. And so and this is for anybody in the team that wants to answer it, but how have you guys approached that challenge, and have you made any ground against it? Have you tried to overcome it in any of your implementations?
I can try to answer that. We've tried to do this because we've integrated other IoT sensors for the same idea, so multi-agent solutions. And what we found is that you can break it down to, especially in GPS environments, maybe not GPS-denied environments, you can break it down to some fairly basic things where, hey, an alert pops, we try to make very small data bits that actually get passed back, at which point that robot knows, hey, I need to look here now, and slews its cameras there, and we could pass that through. To your point, it's hard. We go through, bounce the data through 3 different nodes to get to the cloud to make a choice to come back down again. And getting that off the cloud into edge locally down to even the robot is where it gets hard, because now you're using a lot more compute power to make these choices and these decisions. So that's kind of, you can break it down to smaller data sites, but once those, lovely assets like GPS go away, then getting the metadata you want to pass along enough to make a decision for the other robots to look at it gets a lot harder. So,
Appreciate it.
yeah.
With that, I'd like to open it up, unless anybody has some final words, I'd like to open it up for questions to the group. And we have about 9 minutes for questions. Yeah.
Yeah, I appreciate all the points around standards and lining everything up for standards and having common interfaces, government-owned standards. I think that's like a common pushback from industry to government. It's pretty fair feedback. I'm curious what objections you've run into on the government side and how much headway you're making there. It's like, again, panel full of industry folks, common complaint, but where are you actually gaining ground and tackling those objections?
Gaining ground in standards.
Gaining ground on basically tackling, saying, hey, like, government standards can be far more adaptive to what's going on. Right? I love the Senate, right? Like, make the same thing, run the same common objections of, well, we're defining these, or they're defined out of sync with industry. One thing I think on the AV side is safety standards, right? So military allows 882 Echo. On the civilian side, 26262 and 21448 are like the safety Bible. The two kind of overlap, but you don't get credit for doing one. When you look at 882 Echo and running ATEC. So I'm wondering how are you guys tackling that aspect? And where are you seeing, I guess, the government being more open to using commercial standards as opposed to government standards?
Yeah, I mean, I'll take a PX4 is a great example. If we look at flight control software, I think they're and you could say the same for Autopilot for people who love Autopilot. Autopilot.
No, both, yeah.
Yeah. So I mean, I think that's a great example of PX4 being the one that I'm the most familiar with, where you have an open source standard that has a large enough community around it that is, for most people building drones, and similarly with Autopilot, where you can say, I have a 70 to 80% solution, off the shelf that kind of works, and it's pretty nice. And with a little nudge from my team for, fork the code, go off and tweak it a little bit to suit my needs, I can get my drone up and flying. And I think that that's a really good example in some of the work that we've seen where government has responded to that, has seen that it's a really great open standard, and has said, okay, well, if we can grab that, run it through the appropriate code scans, do our own secure build of it, that we can continue to take advantage of all of these all this good work that's happening in the open source community and begin to incorporate it into our own. And by the way, also maybe get industry performers on contract to make the necessary adjustments to the core code base to benefit not just us, but the broader community as well. And then, similarly, and just, because I know I brought it up earlier, I mean, the, TAC family of systems on the application side is a really great example, where you have and I guess really to get to your point, it's all about who in the government, in what organization is really kind of driving collaboration forward built around standards, and not just around comms, not just around flight control software, but even around just APIs for getting data into a particular application endpoint, into a server environment. And so I guess my last thought on it is just, there are groups out there doing it, but there are certainly many more that are throwing up very clear brick walls to being able to influence and have a conversation around it. And I think that you really kind of see very clearly, whether it's application, flight control software, or anything in between, where the community's rallying. Who are they rallying around? And that's at least been me and my team's approach is, who are the people within government, in our opinion, with our limited advantage, that are doing it right? Okay, rally around them. And then the rest of the community across the service components and all of the various PEOs and PMs will eventually, hopefully, align and adapt to that standard.
And I think, not to overly much talk about DIU, but one of the standards that we've been working on and we've seen work well in the past is we both have RAS-G and RAS-A as subsets of Mavlink. Right now, DIU has been working on RAS-A as basically a specification for C2 protocol as a subset of Mavlink, and that is, I think, revision 1.2 is publicly released. So is RAS-G as a publicly releasable document that Just about anybody can design two if they want to, but we're still, I think, building the environment, building up an ecosystem that has the right kind of incentive structure for people to want to build to it, prior to a product rather than, or prior to the contract, rather than after the contract. Not to rehash the standards discussion from yesterday. Go for it.
Yeah, Jeff Mikowski. I think it was Jeff.
It's close.
I'm from Aerogistic. You guys, this is an excellent opportunity because you guys are all in the launch, land, docking, recharge business.
Yeah, so anyways, so I'm also in the business, and I'm very interested in how the specifications and requirements should be written around these platforms, because they're becoming very important to our military and to our complex, and even in like units. These platforms are now the eyes, the ears, and in some cases the munitions for the troops that are moving forward. So they're pretty mission critical. So in terms of the launch land platforms and even the docking stations, how do we measure the density or the number of deployable units that you can do for like a station? And how do we measure the reliability, because some of these platforms are fairly complex? And so how do we measure the MTBF and the reliability in actual fielded operations, and how should the military go about speccing that?
It's a tough question.
Those are great questions.
In my case, we're not there yet. We're doing MTBF of what we have, right? So we're looking at how well do we operate, how quickly, just how you do normal MTBF on our own systems, and of the drones that we're trying to modify, other people's drones we modify to work with our system. I don't think we're far enough along yet to actually do that, and we're really not the ones that are going to be measuring that. If you take it out in the operational field, you're talking about mission readiness. You're talking about MC rates, mission capable rates, and you're going to turn around and you're going to say, okay, I deployed. Let's just take an example. I took an infantry company, and I've got 20 SMETs, and I've got 40 drones in that. And I want to do a cap, and I think that I can do a cap the full time. I'm making up the numbers here. I'm going to do a cap while I'm moving, through the woods and doing something. And I find that, in reality, you guys told us that it would do these things, and in the operational world, it's doing half of that. And so now we need twice as many. I don't think we can say that yet without getting that operational feedback and actually testing it in those operational hands. But that's how you do it. I mean, the military knows how to do this in all services. Knows how to do MC rates, knows how to actually look at it from a perspective of can I accomplish my mission? And if I can't, how do I do my workarounds? If I can only do it 8 hours a day, what 8 hours do I do it in? And then how do I actually improve the performance? But every system has an uprate today. We're just going to fold right into that system, in my opinion.
Thanks, Jeff. I think that's our time today. If I could really quickly just thank Army Applications Lab for letting DIU step in here, and if I could thank John, Jeff, Adam for joining me today.
And thank
sharing
you
your expertise.
for leading the panel.
Yeah.
Appreciate it.
Yeah.
Thanks.
Thanks, Sean.
All right. See you, everybody.
Sean? All right. We've got about a 15-minute break, guys, and we've got some commercial to defense keynote coming up, so please come back in about 15. Let's say 10:45. All right, gentlemen. Here we go. Hey, Sean. Hey, we're about ready to get started. If I get you guys to get back in your seats. We're going to start again. This is a pretty cool keynote panel, so I want to get a lively discussion on commercial to defense. A couple of pretty good CEOs here. If I get you guys to get seated, we'll get started. So our host today, really of the panel, is our Well, have you been here 2 weeks, Clay? So we have a new deputy director, Lieutenant Colonel Clay McVeigh. He's going to host a couple CEOs from firms we're working with or want to work with. Jeff Cardenas from Aptronek and then Aptonek, and then Dave Merrill from Elroy Air. So I think the idea today, maybe you guys can ask them some hard questions and make it a little more entertaining, is what are you guys actually doing to get to the defense industry? Are you just comfortable in commercial? Obviously, the margins are probably a little higher for you. So think about what tough, interesting thing you can ask them and make this kind of lively. All yours, Clay.
Thanks, Tony. So today we'll have the opportunity to talk about industry's perspective on what the future for robotics might hold. But I'd like to welcome to the stage Mr. Dave Merrill, co-founder, CEO of Elroy Air, and Jeff Cardenas, who's part of Aptronek, based out of here in Austin, Texas. Please take a seat. And if before, as we get going, if I could ask these gentlemen to kind of tell us a little bit about yourselves and then about your companies, of what you're working on, so we have an idea of your perspective as we talk about the future of robotics. So Dave, I'll start with you.
Happy to. Thanks for having me here. Do we have the slides as I talk through a little bit about what my company does?
Yeah.
Great. Okay. All right. Let's just advance through these pretty quick, just to give you some visuals. So we're a UAS maker in the California Bay Area, developing basically big delivery drones for logistics, and it's a dual-use business. So this is a kind of an eye chart, but the summary is we're about 85 people. We've been doing this for 6.5 years, and we're mostly venture-backed at this point, but we're venture-backed by some of the companies like Lockheed Martin and some of the venture firms like Shield Capital that care about dual use and defense technology. So that's been our path to kind of getting the resources together to build the systems that we're building. And if we could advance for a minute here. This is a picture of our vehicle. So we're developing this for 300 to 500 pounds of payload, a 300-mile range. It's a hybrid electric aircraft. So if you've been tracking some of the electric aviation, this is a longer range than a battery electric. And then you'll see it in this video, but we're developing autonomy not just for the flight, but for the ground as well, for pickup and drop off of cargo containers and a modularity of the payload. So we can roll this video and I'll kind of narrate it. So vertical takeoff and landing, comes down, lands in any 50-foot by 50-foot space. And then we built it to navigate on the ground so it can drop off a cargo container, find the next container, pick up the next container, and then vertical takeoff. Once it's up into cruise flight, it's on wings, so that's the more efficient way to fly so we can get long range. And then at the other end of the mission, it'll come down again vertically, deposit the payload, and optionally pick up another one. So we're designing it for high autonomy, light human touch. Logistics in contested environments is what we understand to be the defense use case. Working with the Air Force, with AFWorks, Agility Prime so far on a few contracts. CRADAs with the Naval Postgraduate School and SOCOM. Let's continue. This gives you a look at the mechanism of our cargo pickup. So this is a robotic system that we've developed. We're probably on version 5 of this, but it reaches down, picks up the pod, and then brings it up and latches it. Let's go to the next. This is a look at the standalone system that we built to develop this ground autonomy. So this isn't a full aircraft, but these are all the ground behaviors built into what we call our ground bot. And this is at Travis Air Force Base a couple months ago, demonstrating the pickup and drop off of the cargo containers in and out of the hangar. So this allows a work stream on our engineering team where the autonomy systems are being developed at first kind of apart from the flight aircraft so that we can mature both and then integrate the two together. Next slide. We designed the system to rapidly deploy from a C-130. This was some early AFSOC input that we got, that there's a desire to be able to transport our UAS anywhere in the world and then rapidly deploy it. So it folds up and fits into a C-130 or a shipping container. And I think on the next couple pictures, I've got images of some of the work with AFWorks where we're showing this container fit for stowage. So that's, you can see the tail is folded down and then the wing rotates around so it's 90 degrees and the whole thing gets narrow enough to go into the container or the C-130. Next slide. So this is a look at what it will provide for logistics in a contested environment. So ship to shore, ship to ship, island to island operations where there's a need for robust, zero risk logistics. Similar in many ways to the commercial use case where it's vertical takeoff and landing, long range flight, automated pickup and drop off of the cargo container. We can keep going. I don't want to take too much time here. This is a look at some of our team and some of our AFWERX partners. This is a hangar facility we have at Byron Airport out in the kind of Central Valley of California. Next slide. And a couple more pictures of that. Next slide. This is what we're doing now. So we're doing tie-down testing of our product configuration vehicle. So you can see we've got these concrete barriers, jersey barriers, and the vehicle's tied down, and we're bringing up the powertrain to full power to make sure that everything's checking out. Next slide. Here's another view. And here's a quick video, this is 30 seconds, showing the test that when we brought it all the way up to 100% hover power a couple months ago. So again, tied down, but the team is stepping it up from 20%, 40, 60, 80 to 100% HOGE, which is hover out of ground effect power. So this is one of the final steps before taking it out into the flight envelope expansion with the Air Force. Next slide. Just a few pictures. We've got visitors over like HR McMaster, CQ Brown, AFWERX, SpaceWorks, and let's continue. And work with FedEx on the commercial side. So I think we'll talk about kind of the dual use thing in this panel. Let's continue. You've seen this. Next slide. This is just pointing out a recent phase 2 SBIR that we got with AFWERX for a hybrid electric powertrain that solves some problems in operating in austere environments. Next slide. And overall, I think I'll just leave it here. We could make this the last slide, but we're committed to the dual use premise. We have a big demand backlog on the commercial side, humanitarian, shipping side of our business. And we're really enthusiastic about bringing capability to the DoD, to the warfighter, because we've learned through enough conversations, places like this and other parts of the DoD, that this system can add a lot of value for logistics in contested environments. So that's really one of the first stops on our go-to-market, is making sure that the Chaparral aircraft becomes useful to the DoD for logistics.
Okay.
I'll stop there.
Thank you.
Thanks for the opportunity to be here.
And then could you tell us a little bit, Jeff, about your company?
Yeah,
And your background, too.
Yeah, so first, it's great to be here. I'm a University of Texas undergrad and grad school, and so it's been cool to watch all the growth here, especially in robotics here in Austin. But my name is Jeff Cardenas, one of the co-founders and CEO of a company based here in Austin called Apptronic. I think we got started right about the same time, and we're about the same size, so we're about 85 employees here in Austin. I'm kicking myself now after seeing all those great slides that I didn't submit a presentation ahead of this. But what we're doing at Apptronic is we're building what we call general purpose robots. So the thesis of the company is basically ground systems have to become a lot more versatile to operate in new environments, both in the commercial side and on the defense side as well. Basically, our view is the same thing that's happened in computing is now happening in robotics, right? So in computers in the early days, you had special purpose computers, then you had mainframes. Mainframes to the PC was kind of this breakout moment. And that's what we've been chasing at Apptronic, is this idea of building the PC of robots, right? What is a general purpose hardware platform that could become a software update away from doing something new and performing a new capability? And a big part of that is we have the ground systems. You see the dog robots, the quadrupeds that are out there today. But we're really focused on building humanoid robots that can also manipulate and intervene in addition to just getting around these sort of complex, unstructured environments. And so we came out of NASA back in 2015, so worked on the Valkyrie program there, which was a humanoid robot then. That was a $5 million, 300-pound, pretty slow robot, but it was state-of-the-art electric humanoid at the time, which was our bet that that's where the future was going. And what we're building now is a sub-$50,000 commercial humanoid that we call Apollo. So we've teamed back up with NASA. We have an SBIR Phase 3 with NASA. And we also have an SBIR Phase 3 with the Army as well on autonomous resupply, and really focused on logistics applications on the commercial side for these robots. And so I'll talk a lot about, at least, my view for where robotics is going. But we've had the fortune of working with now the Navy, Office of Naval Research, the Air Force, U.S. SOCOM. We had to get practical about humanoids and say these are too far out back in 2016, and so we took a crack at building the Iron Man suit for U.S. Talos and did 2 suits for them. And the chief engineer over Talos came and worked at Aptronic. And our view really coming out of Talos was that you could think of an exoskeleton like a humanoid robot that somebody's sitting inside of and wearing. And after learning a lot about that, we basically said, well, why do you want to be inside of that robot? If you have a robot, a machine that complex, you could be however far away you want and remotely controlling that. And so that's really where we've moved beyond that. So largely focused on mobile manipulation. We have some bigger systems, but yeah, we can dive into it from there.
Yeah, so that's interesting. You're focused on the ground, you're focused in the airspace, but there's lots of commonality between your 2 companies. And then the Department of Defense and the Army shares those same commonalities: robotics, human-machine interface, autonomy. What do you see as the future of robotics from your perspective, from industry, looking forward?
I can hit it first. And then,
Sure, go ahead.
Yeah, I think we'll probably have different takes on this between what's happening on the ground and what's happening on the air. I think we're at this exciting inflection point in robotics, which is the shift from special purpose machines into more versatile machines. Robots have to be multi-purpose before they can be general purpose, but we're moving into sort of these niche applications for robots to building much more versatile systems. So that's kind of the big trend that I think we're seeing. And, when we came out of the DARPA challenge, everybody thought, humanoids were crazy. I always joke that there was only one thing that was consistent that everybody told us, and that was like, don't do humanoids. Go get a real job and focus on, stuff that's more near term. But we really believed that, hey, this made a lot of sense. And now you've seen folks like Elon Musk come in and say, hey, there's going to be more humanoid robots. I like hearing him say, I don't know that I agree with it at this scale, than people one day. He's predicting that there will be 10 to 20 billion humanoid robots. I think it's important to point out sort of Elon's view on this because, this is a guy who's buying, one of the largest consumers of current industrial automation in the world today. He's buying the largest number of FANUC robots, I think, in the world today. And so if he's got this point of view, then something's there. But if you take the personal computer analogy, think of this like the personal computer in like the early 80s. So, you need VisiCalc, you need Lotus Notes, you need these handful of applications, and but it's the beginning of a new trend and a new wave. And you're seeing sort of the hardware platforms get a lot more mature, but now the software is there to enable it. So you have things like multimodal large language models, you have foundation models, you have a lot of things on the software side that are really starting to make this possible to make robots much more versatile. And so I think that's the next big thing that's coming.
Yeah, there's this adage in robotics that robotics are good for jobs that are dull, dirty, or dangerous, and I think that's very true. Like when we're building for logistics, of course, and what I think I'm seeing is, if you've ever seen the Gartner hype curve of like, you have a lot of enthusiasm about a technology, the peak of inflated expectations, and then there's this crash where people are dismayed that it's not making progress in the way that everybody thought it was going to. And I think we saw that, and then now we're up this kind of climbing out into truly useful applications. And so when you look at like where have robotics already achieved scale out in industry, it is these kind of dull, dirty, dangerous situations, or the ones where they don't have to interact that much with people. Like, speaking of Elon Musk, if you've ever visited the Tesla factory, you can see these robot arms, welding and spraying and just building the chassis of these cars all the way through. There's no human being in that environment, and that's why it's a great scenario for robotics, because you don't have to worry about the same kind of safety factors as you do if you're going to put a delivery robot kind of out on the sidewalk right here, walking the streets of Austin. And so for us, what it means is, up in the sky, there's a lot of open space. We can keep well clear of any other vehicles. It's an environment that's good for robotics and automation because it doesn't have to solve these problems of operating in really close proximity with people or vehicles. And so I think that's what you're going to see more of, is these specialized situations where it's kind of like safe enough and the use case is well motivated, and you'll see these real use cases taking root.
So if we follow that concept from multi-purpose to purpose-built, where do you think the Army is along that spectrum right now? And are we heading in the right direction from your perspectives?
I think the Army is kind of experiencing the same thing that the commercial industry experienced, over the last, call it 10 years, as you've had systems out in the world. So if you just follow the trends that have happened on the industrial side. So in 2004, the big innovation was collaborative robots. So getting robots out of cages, and now you can start to put a robot with and around people. By 2010, batteries got good enough, compute got good enough, we could start to have mobile robots, so that was AMRs. Then, we started to get machine learning taking place, we could start to use cameras and vision, so you had intelligent picking happening. What you're seeing is all that stuff coming together. But the challenge was for the companies that are adopting this, and really if you think about robotic density, it was all in manufacturing. What came next after that was logistics. It's really only in those two industries at scale. You're starting to see it bleed into some of these other commercial industries, but largely logistics has been the big, new frontier over the last 5-10 years. But the challenge that they had was they had so many different special purpose robots that it became untenable for the big companies. Dave mentioned he's working with folks like FedEx. Well, they had one company doing vision-based grasping and picking parcels. They have a company looking at truck unloading. They have a company doing case picking. They have a company doing, and it goes on and on. Another company doing the hardware, somebody doing the data analytics. There's the warehouse management system. And so it became this highly fragmented space. And I think that's what you're seeing with the Army right now. It's like they're waking up and realizing, okay, this is possible. But there's so many point solutions that are all doing sort of one-off things. And my view, and this is where we're seeing the pull from commercial industry, is you're going to have to start to get to more commonality of platforms and more versatility on these platforms so that it becomes tenable. So everything's talking together. And so that's what, we're working with some of the biggest retailers and manufacturers and logistics providers in the world, and that's what they're coming to us for now, is they're saying, hey, I got 20 different vendors. I can't manage all of those different vendors. What if we had one robot and one platform that could just do all of these different things? And so that's what I think the next frontier is focusing, consolidation. So first, you got to prove out viability. You got to prove that this stuff is possible in robotics. But then there's going to be sort of a consolidation, which we're seeing on the other side. The other thing that I think is important is that robots have to become a lot more affordable. So, right now the Army's adopting these very sort of expensive, exquisite machines, and this has been the trend in robotics. It's all about ROI. So first, in commercial side, it was like, can you do it? Well, what you've seen in vision-based grasping and logistics and other spaces is a robotic work cell that's $200,000, it just doesn't pencil out, right? It doesn't actually, even if it works and the technology is there, now it's been the shift from performance to affordability. And I think that if you look at the future of the fight for the military as a whole, that same shift has to occur. But on both of these sides, I think, the DoD as a whole is going to be able to leverage all the things that are happening on the commercial side in a big way. And we can dive in deeper. I know we talked about that question, but I don't know what you think, Dave.
Go ahead, Dave.
Yeah, I'm not an expert in what the Army's doing with
Yeah,
robotics.
sure.
So, with humility, I'm here to actually learn more about that and see if there are connections to be made. I think, though, kind of from watching from afar over the past 5 years or so in our space, kind of cargo drones, what I would recommend is just kind of getting to know the industry even more, kind of more points of contact. Like whenever we talk to anybody across the DoD, we usually learn something that helps us shape the product. So kind of more engagement, more frequent engagement, and then you probably hear this from every company that aims to work with the military or does work with the military as a small business, but starting to kind of place bigger bets where the contract size goes beyond a kind of early SIBR phase 1, phase 2. That's really what kind of gets a company's attention and can kind of start to sustain a company in the direction of actually working with the Army or other parts of the DoD.
Yeah. So, listening to General Rainey's introduction speech yesterday, he talked and addressed some of the things that you both brought up, leveraging industry, modular mission payloads, having a vehicle that we could attach things to that could then do multifunction things, and then affordability. He also addressed, like, we need to be able to make these attritable and not be, hundreds of thousands of dollars for a unique solution that works like that. Where should the Army follow industry, and where should the Army lead industry? And when I mean Army, I mean Department of Defense in general. What is our role in this sphere?
Well, in my perspective, the industry's role is understanding the enabling technology, what can be built, and trying to figure out the business models around it. And so for a company like us, that means figuring out the dual-use business model where FedEx wants to use these systems for warehouse-to-warehouse shipping. Okay, that's a big scalable opportunity, and there seems to be a good use case for logistics in a contested environment for systems like this. So I think our job is to kind of match emerging technological possibilities to capabilities, but what we need is both that kind of early and often contact, so we know what the needs are, and then that ability to kind of engage quickly when there is a good fit between the technology and a need, and sort of ratchet up an engagement to sort of a funding level that allows a company to focus on it.
Okay.
Yeah, I mean, I would agree. I think, simply put, right, what commercial industry can bring is the technology, a perspective of what's happening in the commercial markets. What we need from the Army is to understand the use cases, and we need to understand the unique requirements that the Army has. I think, the idea of dual use is great, but fundamentally, there's things that are similar, but there's also differences of what the Army needs and the DoD as a whole needs compared to commercial industry. If you understand those things early on when you're building a complex system, I mean, Dave's building an aircraft. These things have to be certified. They take years, to be certified. If you don't get those requirements in early, it becomes very difficult to change that on the back end, or very expensive, at least to say the least. And so I think having those conversations early, and I think that's one of the things that I've been so excited by of watching AAL and Army Futures Command grow is, before we didn't have any access to end users. And through several of the programs we've been a part of, we've had a chance to talk to end users early on, and I think that's a dialogue that needs to continue. So I think that's part of it. The other thing that I think, and this is kind of the dirty secret of the technology space, is that, every piece of technology in a cell phone, a modern smartphone, was funded by the government, right? Everything. The same thing's happening in robotics as well. Actually, most of the underlying technologies were funded by the DoD, funded by DARPA, they're funded by SIBRs, they're funded by these early technologies. But the challenge is it's so difficult to work with the government that what you see the best companies do is they take the early R&D and they get funded with early R&D, and the second you have a viable product, you can't, you'll get killed, frankly, by trying to work only in the government. And so you go exit to the commercial markets and go sell a commercial product, and then maybe you come back or maybe you don't. And so there's been a lot of missed opportunities, in my opinion, because we do need the government to fund these, really innovative things like quantum computing and robotics in the, 10, 20 years ago, and continue to fund this stuff because the commercial market can't take it on yet. So there's kind of this twofold. At the early stages, I think that's where the DoD can play. They can shape these, make these bets that commercial industry won't be able to make. And then in between, once the technology is more mature, really informing that product roadmap as well.
I think that's a great point, and I want to plus one and add a little bit to that, that there's there's a way in which the dual use premise can kind of, I think, lull people into thinking, from the military perspective, well, I can just kind of sit on the sidelines and wait until that technology is ready, and then I can pick it off the shelf. And I think that's really risky to do that, because for some of these core technologies, whether it's because of the kind of early technical risk or the capital intensity, like those technologies might not get to the finish line if they don't get early substantial participation. And so even if they do have an even bigger eventual market out there in the commercial world.
Yeah, that's right on.
So let me kind of regurgitate what I heard, if that's okay. The government's role should be to make big bets early on in basic research. The second part of that is we need to clearly articulate our message and our problems so that industry can come in and address those. And then the third part of that, as you just said, is maybe to help facilitate that process, allowing industry to tackle our problems along the way and don't just be completely hands-off. Is that fair?
Yeah,
Yeah.
I think you just made a good point. You think about just like our near-peer adversaries, everyone's thinking about a big one on the other side of the Pacific, but they're able to make bets over a long time horizon. When you look at something like humanoid robots or even exoskeletons, which we participated in, these were like moonshot sort of things that you had to think long-term about. Well, our Chinese counterparts were getting hundreds of millions of dollars, only to a handful, maybe 4 to 5 companies that got that, but they got big long-term bets. And we're going to have to do the same thing here. It's a real challenge to build something that goes from 0 to 1, on even $2 to $4 million contracts, which sound big, especially $1 million contracts. That just gets you your foot in the door. That gets you close enough to the edge to fall right off of it. $2 to $4 million maybe builds a ramp so that you have more velocity when you hit the valley. But really, these need to be like $10 million plus bets over time. And, while you want it to be milestone based because you want the companies to perform, it's a challenge if you have a 9-month milestone to build something that's going to go from 0 to 1. You need to be able to plan over, let's call it a 5-year time horizon to be able to do something. And so the budgeting cycle is always a challenge because these are 2-year sort of budget cycles. It makes it very difficult to really plan for the long term when you're doing that. And so I think jointly working together on that is something that I'm seeing a lot of evolution in this before. When we got started, I wanted to be dual use. My dad was a retired Air Force colonel. My granddad retired Army colonel. And I believed it's a fascinating story on robotics. It's too long to go into, but the U.S. funded essentially the first industrial robot and then didn't continue to back, the government as a whole didn't continue to back it. That company ended up folding and sold their IP over to the Japanese, which ended up building these, massive industrial robotics companies out of the ashes. So we lost out on the first wave of robotics, even though we invented it. And so when we got started, it was talking this idea of dual use, and every VC I talked to said, look, dude, you're one or the other. If you're either need to set up to go work with the government, and if you do that, you need to be having someone in Washington to play the long-term game, or you need to go after the commercial markets, and then maybe later on you can come back to the defense market, but you can't do both of these things. That's shifting, but the way for that to shift, I think, is to, for these groups to work together and really both sides put in equal amount of capital. And you're seeing that with what the Air Force is doing and Catalyst now with what the Army's doing and other things, but we need more of that if we're going to, be building things at the level that we want to over time.
There is, by the way, as I'm sure a lot of you know, a growing number of investors who care about national security and are investing in dual-use companies and companies that are building defense-relevant technology. But they're still kind of a corner of the overall investor space. They are not the majority, right? For the majority of investors, whether they're venture capital or private equity, I think we have a panel coming up on this, but their job is not to be interested in the national defense. Their job is not to be interested in robotics or aerospace. Their job is to take this much money and turn it into this much money. And if it happens to align with the national defense, great. but that's not what they're optimizing for. So that's why, again, I say it's a risk to kind of leave it to chance for critical technologies that the DoD needs, to leave that to chance and think, oh, the commercial markets and the investors are going to fund that all the way until it's ready for us. That's a risk.
And just to, I guess, maybe articulate a little more why investors don't, I mean, it's not because they're not patriots. The reason is because there's this cliff after SBIRs. So you get an SBIR and a startup wants to say, hey, look, I've got traction with the government. I have a product that they want. Well, if you really dive into it, you realize that SBIR money is free. It's not coming out of anybody's budget, and no one's actually really making a bet on that thing. So it becomes a very difficult signal. So kind of the new investors, the old investors, like I've talked to investors that have been around, through the 80s and 90s, and they're like, I don't touch any of that because every one of those companies dies after SBIR phase 2, right? And so you have these new investors that are coming in, seeing all this activity. Oh, you just got $1 million contract. This looks like traction. You're moving ahead. Well, the real problems are going to come after the SBIR phase 2 is up, and so it's got to come out of somebody's program and come out of their budget. The way to solve that problem is if you can give a company a longer-term contract, and that's something that investors will be willing to make bets on, right? Okay, if you got a 5-year contract, I see that it's budgeted, I can actually make a bet on that then because I know you're going to be around and I know that there's real skin in the game. So I'm sure they'll talk about this on a later panel, but it's an important thing, an important signal, I think, for this to work.
Yeah. No, I appreciate y'all's perspectives. Let me ask you, in your experience, I think you've been around almost 7 years, 8 years, it sounds like.
7 years as
7
well,
years
yeah.
as well, okay. What has changed as you thought were big problems 7 years ago? What are big problems today, and what do you think the big problems of tomorrow will be that you're facing in your respective areas?
I mean, I'm a technologist originally, came out of computer science degree back in the day. I think, rewinding, we were solving, 7-10 years ago, some of the more basic problems of autonomous drone operations, like can you make a system reliable? Can you make it fly A to B? How do you make it not crash into things? And so there's been a ton of progress in our industry on these kind of building blocks of autonomous flight. Those aren't kind of unobtainium, they're not rocket science anymore. And so now I think companies like us the problems are, okay, so how do we make this thing now robust enough to go out and serve, years of missions? And, with aerospace, sometimes you don't know how long a part is going to last or an aircraft is going to last until you actually fly it years, and you find out what breaks. And so we're now entering that kind of learning phase of not just can the thing work, yes, it can work, and now we're learning up like, okay, how do we make it robust and last the amount of time that the customer needs? Fortunately, we have some advisors, like, we raised some money, like I said, from Lockheed Martin, so we're trying to kind of probe that organization to find out, okay, well, who can we kind of bring alongside us to help, grab somebody out of Sikorsky who knows about marinization, grab people that have done some of these problems that now we're entering the phase of, and kind of make sure we sail through that.
Yeah. Okay.
I mean, I think as you grow a company, there's all sorts of problems that you encounter over time. It's hard to do this kind of stuff because it does take long-term thinking, and it takes a lot of capital, frankly. These are just, venture capital was really designed initially to fund software. Well, as you look at real assets, something like building a humanoid robot or building an airplane, it's a fundamentally different thing. And so it requires entirely new ways of thinking. And we're at the beginning of that. We're seeing this shift into sort of real assets being the next frontier. But the nature of the economy, in my opinion, the way goods and services will be bought and sold is really going to change. We're at this turning point that's maybe the same or bigger than like the internet, right? Like, this is really a dramatic shift, and so I think there's many challenges. The biggest one that I can see right now has to do with supply chain and the demand for these systems. There's demand for millions of units of these types of systems, both on the DoD side potentially and on the commercial side. And where are we going to get the, where's the supply chain going to come from? And so one of the things that I was always, sort of my thesis coming out of grad school was that Mexico was going to play an important role, Texas-Mexico corridor, for both the manufacturing and supply chain for robotic systems over time. And so, I think COVID became a real accelerant for the challenges in our supply chain. It's one of the reasons that, logistics is a good place to work on the commercial side, I think, for both of us. But if you think about how that plays out, we got to start thinking longer term. It's not just enough to basically have the systems and the capabilities. You have to think about where you're going to get those from in the future and build the capacity to be able to deliver at scale. And that's something that I don't think we fully have a handle on. And once you break it down and you get all the way down, there's still a huge number of components that we're getting out of China or Taiwan, and that's going to be a threat for this industry growing over the coming years.
Yeah, interesting perspective. Okay, so before we do question and answers, one or two big bets that you would throw your money in if you had a lot of money to throw. Where would you put it? Dave?
Well, I don't have a lot of money, but I have my time, and so I'm investing my time in autonomous logistics. I mean, we've talked about it a few times, but the movement of goods is this constant drumbeat across the whole planet. People need food and necessities every day, so it's this massive industry. It's not going away. It's only growing, and so I think I remember talking to Amazon years ago and just heard this idea that stuck with me. Like, they have such scale that any improvement to operational efficiency immediately pays off, almost no matter what it is. And so I think, operating in an environment where there's a really obvious, real human need that's huge and growing, like logistics, is where I place my bet.
Yeah, I mean, I've placed a similar bet with my time as well. Sure. And I think this is something that I'd like to see more attention be focused on. There's a lot of talk about, sort of capabilities and systems, but what's underpinning and where you see most of the people working, I mean, we had a chance to work on Field Artillery Autonomous Resupply, the FAR program. And, I mean, they're just throwing bodies at, loading and unloading these trucks, right? 10 to 20 people in a stationary position that are loading and unloading these trucks. If you free those people up, what else could they be doing? And we have challenges with the, rates of people that are joining the forces today. And so, using people more effectively is a big part of that. So, my big bets are, I think, logistics. I think that is the best sort of dual use application. I also think from a doctrine standpoint, when you think about where you can apply autonomy and machines, it's a no-brainer. It's like, it's just a clearly sort of good thing to do to get people out of harm's way. And there's a lot of new capabilities that you could open up by doing that. So logistics. And then, this is self-serving, but general purpose robots, I think, is going to be a big one as well. I think this idea of optionally manned makes a lot of sense. And if you can build machines that can use all the same tools that we use and can operate all the same systems and go in all the places that we can go, I think that's fundamentally going to change the game. And if you look at our population relative to our near-peer adversaries, where some of them have 4 times the population that we do, I think the stuff that's happening here in this room is, where you place your bets over time.
Okay, thank you. So I'll open it up to questions we might have from the audience. Yes, sir.
Really interesting points on the supply chain piece. And I guess the challenge, though, is that you're building very innovative technologies for an uncertain market, but you're also being told to develop something that's robust enough for an operational environment, but also affordable. So I guess, how are you guys considering your builds, and especially from like the general purpose robotics piece? How are you kind of keeping an eye on making sure that it's affordable and within that entry-level kind of boundary, all while balancing out things like a very expensive supply chain, trying to reshore everything in the U.S.? I think it's a really interesting challenge. I'd love your opinion on it.
Yeah, so this is going to be somewhat technical of an answer, but I also think there's like a macro point to this too, which is that, there's this kind of question like big versus small companies. What can small companies do that big companies can't? And I mean, the answer to that, in my view, is we can take a lot of risks, because we have to. We have to make a lot of bets if we're going to survive and we're going to create something big. And so, one of those bets is from the Apptronics side. Our bet was that robots would need to be built in a fundamentally different way. So one of the things that drove cost for robotics over time is that they were designed to be pre-programmed to do very high precision tasks, right? So you're pre-programming a robot, it's doing the same thing over and over again. The spec of a robot is 0.02 millimeters of repeatable accuracy over 80,000 hours, right? So very highly precise. Well, that's expensive. That's also a very difficult thing to scale manufacturing for, to build things, tens of thousands or hundreds of thousands of machines with that level of precision. Well, as you have AI now, you don't need that same kind of precision in a machine anymore, right? You need orders of magnitude less. Maybe you need 1 millimeter or 2 millimeters of repeatable accuracy. Once you remove that sort of precision constraint, it fundamentally changes everything about how you can build a robot. The problem is everyone's basically, because of the challenges and the complexity, the robotics community was basically iterating on the same designs for a long time. So as we started to open up these new unstructured applications, people were basically taking these old robot arms and then just applying them to the new use cases. Well, we were maybe naive enough, but also ambitious enough coming out of school to say, look, we're going to build robots in totally different ways. We don't need the same level of precision. We need to be safe around humans. We need them to be energy efficient. We need them to be lightweight. Well, that allowed us to start to leverage ideas from car companies and other places. My question was, why is a robot arm, the size of a briefcase or something, $50,000, and you can buy a BMW for $50,000, right? And a lot of it had to do with this idea of precision. So to give you sort of background what we did at Apptronic, we built over 30 unique different flavors of electric actuators, sort of getting towards the premise. This is something that we did out of necessity because we had to. We were swinging for the fences. Someone told me this early on. They said all of our robots were avant-garde, which was not meant to be a compliment at the time. But they were all different. We weren't building them like anybody else was building them. We were trying to do new things, and we were brave enough to try things like exoskeletons and humanoid robots. The answer to your question then is that if you rethink the way that you're building a machine for new requirements, then you can design something from first principles to better meet this. And so now we're actually able to leverage. Turns out right here in Texas, we're building things like ball screws and planetary gearboxes and other mechanisms that are going to become very relevant to the new way that we can build robots. And those are much more affordable. Supply chains are more robust. We already have people doing that here in Texas and in Mexico. We already have supply chains that can support it. So if you're just able to zoom out and think longer term, then these are problems that you can solve pretty easily, both on the operational side and on the science side as well. So long answer, but hopefully that answers your
We
question.
might give you the last word unless, Dave, you have any last thoughts.
Just to follow up on that, I think it's a good question. I'll rephrase it as like something like better, faster, cheaper. How do you do all of that? And to which I might say, pick two. We're always building within constraints, and we always got to decide what we're optimizing and what we're satisfying. We're not going to optimize every dimension. But I guess the way of working different, kind of to riff on what you were saying, is figure out which constraints can be loosened. And for us, what we've done with that idea is, well, let's build the first generation of our system as an aircraft that's robust, but not FAA certified level, because that requires a lot more time, a lot more capital. Look at the teams that are building air taxi vehicles for human passengers that need to be FAA certified from day one of operations, and they've got 500, 1,200 people on their teams, and they've had to raise billions of dollars to get that kind of a system to market. So, loosen a constraint. For us, don't build a certified vehicle from day one. Build a robust, good vehicle from day one, but treat that as like a second step. Build the first chapter of the business in a way that has loosened constraints.
Very good. Gentlemen, I thank you for your time. I feel like we were just getting started, and I would have enjoyed continuing this conversation, but thank you so much.
Thank you.
Thank you.
Thank you, guys. You guys sit tight. We got one more coming up here before lunch. Get back into system discussion. So our moderator is from Acme General, David Bonfili, who I've gotten to know a little bit here. He's been around since the beginning. I think 4.5 years ago he got started at AAL. So panelists are going to be, I guess, Joe Francesson, who's running operations out of DC at High Point Aero Technologies, as well as Ben Van Bergik, who's at OSC, and Travis Bale from Booz Allen. So I'll let David get a little bit more into what they do and how they do it, and start the discussion. Yeah, I'll get you another. All right, you guys want to come? So one of you doesn't have to stand. Move this over. All right.
Yeah. All right, well, let me make sure my mic's not going to blast you out of the room here. So thanks, everyone, for sticking around. I know we're the last panel before lunch, and that's always a difficult time slot on day 2 of a conference where you've probably been enjoying some of what Austin has to offer in the evenings. We're going to try and do something a little different for these private capital panels today, which is, I think what often happens is we trot out the same venture capital firms that are either at big blue chip shops or at small startups, and they say sort of the same things, which is the government needs to be a better customer, we need to have higher profit margins, you need to move faster, make bigger bets, and all of that's true, but it's maybe not the whole picture. So what we tried to do in pulling together the panel here today was to bring some people who could talk about the private capital piece of funding DoD innovation, hardware and software, from a little bit of a different perspective. So I'm going to let them really talk about what they're doing themselves, but just to give you some context, Captain Ben Van Buskirk recently left the Office of Strategic Capital, where he was the founding deputy director there. And so I guess let me ask right now, how many people are familiar with OSC in the group? Some, but not all? Okay, so I'd like Ben to tell us a little bit about what OSC is doing and why it exists and how the government's thinking about attracting private capital there. His perspective is pretty interesting because in addition to having served at OSC, he was the director of Naval X, so the Navy's front door for innovation prior to that. So great perspective here. I want to make sure that you all have a chance to ask questions as well, so it's not just me talking, but that's Ben. Joe Francesson is coming from High Point Aerospace Technologies, which is a really interesting play that I want him to go into more detail around. But the sort of premise was, rather than just building individual companies from the ground up, is there an opportunity to look at existing companies, pull them in as a roll-up, and build something that has a little more mass and scale? And so he'll talk about where that's coming from. Also, fascinating background, formerly Deputy Assistant Secretary of Defense for Special Operations and Combating Terrorism, also a former Senior Director on the National Security Council, and time at the National Security Agency before that. And then last, Travis Bales from Booz Allen. Travis is Managing Director with Booz Allen Ventures, which is a relatively new platform there. It's their corporate venture capital arm that they launched last year. And it looks a little different from some of the other corporate venture capital arms that we see at places like Lockheed Martin or RTX. And so I'd like Travis to sort of unpack what they're doing there with private capital and how a corporate venture partner like Booz could make sense. So that's sort of the big picture on where we're trying to go with all of this. If you have pressing questions, I'd like this to be as much of a discussion as it can be with a room full of people, but don't think you have to wait till the end, raise your hands, and we'll go out and grab those if they're timely and appropriate. That make sense? Cool. So let's start with you, Ben. You recently left the Office of Strategic Capital. A lot has been written about it. Jason Rathje, the director, has been making the rounds and talking about what the sort of purpose is and what the agenda is. Can you sort of give us the high-level picture of why OSC, why now, and what the focus of the organization is when it comes to attracting more private capital into the space?
For sure. Thanks for having me. It's always great to be back in Austin at the Capital Factory. So those of us, like we just said, we came from the innovation space. I was at VMware, even before NavalX, I was a fellow at VMware. Jason Rathje came from AFWorks. So we've had this experience in seeing where the challenges are. So OSC, it's at fundamental level, we realize that there's lots of innovation going on, but we've got a ton of capital out there that for various reasons isn't going to our companies, and why is that? So we did our research, and I think a great way to think about it is going back to where we were. That there was once a time that private capital, and I'm not just saying venture capital, we're talking private equity, family offices, other methods, forms of private capital, for decades drove our defense industry. It was a huge aspect, and something has happened really since the 90s, and there's a lot of reasons. I won't go into the details here, but the capital isn't flowing like it used to. It's going into other sectors. And so how do we get back to where we were? How do we get private capital back? And what kind of tools can we do to provide financing, and we use the term patient capital, to companies and investors that want to do this sort of deep tech investing in defense, I'm sure we've had all the discussions about why the DoD is a hard customer. But what can we do to bridge that gap? So the way we have gone about this is we formed our office, and like we talked about, like David said, I turned over, so I'm speaking on behalf of myself. I'm not representing OSC, but that's very liberating too, as I can be myself. But the office was stood up it was led by the SecDef, so SecDef leadership helped us get there. But we have 4 lines of effort out the door for the office, and they're made to attack different aspects of innovation where we see challenges. And you can look at it as multiple valleys of death. It's not just one. You have lab to prototype, financial challenges, prototype to product, and product to scale. So a handful of tools to work those. So at the very foundational level, we have Transition Acceleration Program, which is very similar to what AFWorks has with their StratFi program. This is where a service sponsor says there's a company, I really like them, I have money, but just not, I would like more. And so what we can do is take our funds from Office of Strategic Capital, put those together, and then get crowdsourcing private capital on top of what the government's already put in. So it creates a financial multiplier.
Sorry, but when you're talking about that program, do you have sort of an order of magnitude for what those checks look like?
No. We can do small to big. The highest we can go, because through the TAP, we're leveraging the SBIR program. We can max out what the SBA will allow as a waiver on a follow-on phase 2. That's the max. And so we aren't limited by the 2.5 million. So it really comes down to, you can do a pretty big deal if the government sponsor will put in a large amount of money, then we can get the waiver with the SBA for a concurrent phase 2 for a decent amount of money, and then we can go to private capital and ask to match. That's the foundation of what Transition Acceleration Program is. It's led by that government sponsor saying, we want this company, we just need more money. The others, we're calling OSC overseas. We've seen the challenge in working with NATO, with AUKUS, and we have capital in other countries that want to participate. We have great startups in other countries, but we don't have a lot of vehicles to work with them. So we're working on a project right now, hope to have money flowing by the end of the year, where we're partnering via a 501c3 that can invest on our behalf. So you can pool, and I won't name names of organizations that do this, where you can pool funds, international and domestic, to a 501c3 that based on a certain guardrails that we would place on what we have with our investment thesis that matches theirs, they would invest in international companies. The third, and we just made an announcement a couple days ago through the SBIC Critical Technology Initiative. This is working with the SBA on authorities they already have to provide funding via SBICs to investors so they can then invest in defense technology companies. It provides funding in a way that makes a lot of sense because, as we all know, it's a hard time to raise capital. We can provide funds that investors that want to raise capital borrow money from the SBA, working with us at DoD to then go make investments in startups. And then the last is a direct lending program. Also, this should be done by the end of the year. This is our ability to create loans directly 2 companies that need them for scaling. Right now, we're working through partner agencies because as we're a new organization, we're working on the legislation, which luckily is going really well. But for now, we're partnering with agencies that already have it, so we can learn as we grow our teams. When we get it ourselves, we go full speed. So that's where OSC is right now.
If I could push in a little on the SBA program. So one of the concerns that's been raised around that is that if an investor is having trouble raising private capital from LPs and the government is stepping in to provide that capital, does that create a negative selection bias where the investors that show up for that program and are willing to accept the covenants that come with operating with government funds aren't maybe the investors that you want to show up? Is that a concern, or do you think that's overstated?
It's a concern, and our answer to that is we understand that in a lot of ways, the business model that traditional venture does, there are technologies that we have, and being a Navy guy, I've seen a lot of great blue tech technologies that the DoD needs, but there isn't a large TAM for it. It's hard to create the business case for investing in that. So we don't think we are competing with other private capital in that way, or we don't think we are overriding market forces that are saying this isn't a good investment. The bottom line is there are critical technologies, and the office will be publishing our investment thesis here shortly. We really looked at the fabric of the 14 critical technology areas. Where's capital going, where it's not. But there are certain areas that we need help with, that we will not get there ourselves, that investors aren't going. But if we can sweeten it to a point to make that a reasonable investment, it's the right thing to do. So we don't believe we're competing. We need to provide the proper incentives to get investment back in these areas that we need to do to win. And that's really where this comes down to, is we can't do it alone in defense. The POM dollars aren't going to get there. We have to be able to figure out newer or some kind, these are proven ways, just tweaked, to get capital back in.
The other observation that some people have made looking at the initial OSC programs is that they seem to be geared towards supporting earlier stage investors in the venture capital space. I guess, A, do you think that's true? And B, regardless, are there efforts to appeal to growth equity, to the larger established private equities? Are things like public-private partnerships at scale, where you're talking about billion-dollar deals, not $10 million deals, the sort of thing that are within the mandate of OSC, or do you see that as belonging someplace else?
My personal opinion is it is. We're starting off. We go, where can we start now and get traction now and create success and then continue to build? If you look at the innovation pipeline from that lab to product to scaling, the direct lending program is more targeted towards more mature companies. So in itself, when that comes, that is targeted towards more mature. But we do see that in the future. And I will say some of the companies, just from my time there, are PE-backed companies that are more mature, like Transition Acceleration. It doesn't have to be, have some backing from private equity. There are some rules, but yes, we do have PE-backed companies that we're working with. So I see that in the future. So we aren't limited. It's more of the where do we start now with authorities we can get and the people we can partner with, other agencies that have those authorities while we build it out. So I do see that in the future.
Cool. Joe, can you tell us a little bit about High Point Aero? Because I don't think it's as broadly known as maybe it should be, and it's a pretty interesting model for bringing private capital to bear in the space.
Sure, thanks Dave, and thank you all for joining today, and Austin Capital Factory for hosting us. Really enjoyed this event and getting down here and understanding what all is being done down here, and the kind of the possibilities for innovation going forward. So I'm Joe Francescan. I am what I would consider a recovering government guy, so it's my first foray into the outside world. It's been fascinating, learning a lot. I'm a part of Highlander Partners. So Highlander is the overall financial overlords that control us. They are a private equity group that is driving this forward, and High Point Aero Technologies is the counter UAS instantiation, our counter autonomy group that we have formed through the acquisition of both Lyddite Systems and Black Sage Technologies. So we kind of went into this with the idea of let's create an irregular warfare prime contractor over time. I can say that to this audience. I think people understand where we're trying to go with irregular warfare, but our first acquisitions then were in the autonomous and then the autonomous defense spaces. And so with Black Sage and LiDAR, we also added design technologies on the autonomous space. And our goal here is to design and build systems that are interoperable, modular, that are applicable for both defense and non-defense solutions. So it's been interesting. It's been 7 months. We just relaunched the High Point website. You guys are kind of the first test audience here, so you'll see more publications, and we'll make a public splash here in the coming months. But it's been really fun, and we have Al here as the CEO, if anyone wants to say hi and see what it's really like to be acquired and kind of go through that experience of what it looks like. So I've been pushed down into all 3 companies to kind of run the government affairs, the Washington operations, and some of our international efforts as we look to expand and grow these companies. Autonomous defense space, very interesting right now, and with General Rainey's comments yesterday, I think we're going to have a kind of a come to Jesus, or certainly an opportunity for the Defense Department to really step up and either make its commitment known to autonomous technologies, or the private industry is really going to kind of go in a different direction. What I mean by that is you have counter-UAS in particular use cases that are far outstrip what DoD is doing right now. And DoD wants a very highly specialized system that's very exquisite and very expensive, but it's not applicable to the private industry. And frankly, if we're looking at the private equity model, the investor model, the profit margins are a lot higher if we're selling to more customers on the outside in the commercial areas. So where are we going to go there? DoD also has some very restrictive processes regarding testing and acquisition and that sort of thing. I'm sure we'll discuss more here. But I don't want to beat those dead horses, but there's a problem here that I think we can address and work together on as we go forward.
So, Joe, when I hear you talking about the customer base, I hear you talking about both a government base and a commercial base. Is that correct? Is it also correct that it's both a domestic and an international customer base? How do you think about the audience for what you're building?
Absolutely. So Black Sage Technologies, now part of High Point, they've actually, most of their sales and efforts are done overseas. So we have a very prominent contract with Changi Airport in Singapore, where we're providing a counter-UAS and we're conducting electronic warfare on active runways. We can't do that we're nowhere near that here in the US. And the innovation that they're designing and building out there, and the customer set and what they're defining, they're not defining the solution, they're defining the requirements and the modularity of what we're going after, the software, the ability to upgrade substantially is far and away different than the approach taken by DoD, where they are defining, the JCO is still defining what is counter-UAS, what is the definition, what are we doing. Even having gone through the whole JCO certification process, they still haven't acquired anything off of their JCO-approved good housekeeping seal of approval. So I see tremendous growth opportunity overseas. There's a U.S. interest in getting out there and doing this before some of our competitor countries are moving into these markets. And so that's really great. And then domestically as well, everything from advanced air mobility is essentially a counter-drone problem as we go forward. So cities are going to need a citywide counter-UAS solution. It can't be a $5 million gun truck that we're toting down the streets. So how do we design that? And if we design that, that's a lot different, and we're putting in the capital on the investment side, it's a lot different solution than what the DoD is requiring. So how do we square that circle will be interesting to see, but to understand that from a DoD perspective, and I don't think DoD understands that they're about to be left behind if they continue down this similar path.
When you're looking at acquiring companies, is there a check size that you have in mind? Like how big is too big, how small is too small?
Sure. So Highland is a $4 billion assets under management right now. They're sitting on about $1 billion in cash, so that's probably our upper limits. But we have acquired companies in the tens to hundreds of millions so far. We are really looking for something that fits in that autonomous space and that are add-on technologies. So LiDAR and Black Sage were both integrator technologies. They weren't the actual solution for counter-drone, but they were the software-defined where they could really advanced radars, and we can work through that. General Rainey's comments yesterday again about what do we look at with an urban environment versus some of the forward-moving environments. I think that's the future of counter-UAS, where we are swapping in a radar for a counter-urban environment, and then we're swapping out one that's more attuned to longer distances and longer ranges. So we want solutions that allow that portability and be able to meet a bunch of different ways. And then also the ancillary technologies, the software, the AI, how do we build that out as we go forward?
When you're looking for companies to acquire, are you finding it to be a target-rich environment? There are a lot of interesting things to look at, or are there really a relatively small number that you think sort of fit the spec for you? And related to that, when you're in the process of trying to negotiate these deals, to the degree you can talk about it, who else is around the table? What's the competitive set for you look like in this acquisition space?
Sure. So it is a very target-rich environment, although I will also caution that private equity is a four-letter word with a lot of companies, in particular in innovation spaces. So I understand, and what we try to present is a model where we are coming in with a strong defense background. We have a former Secretary of Defense. We have primarily special forces focused groups or people that are helping to advise our defense practice. And we're taking this with a rapid innovation mindset of how do we help grow your companies. We stay out of your business. You go back to doing your technical skills that grew this company, that designed it, and we'll help you bring in Highlander's expertise to help run the operations of the business, and we'll help open and unlock those doors for the Special Forces, SOCOM, some of the advanced development programs that are out there. So that's been a unique model, and I think that's what really sold the three companies that decided to go with us. In terms of competition, there are a couple of other private equity groups out there. Arlington Capital Partners, I think, that's doing very similar things through Blue Halo and what they've acquired in both the counter-UAS, the space, and the autonomy spaces. Anduril, which obviously a big monkey, a big elephant in the room, but they've gone from counter-UAS to now rockets to all over the place. So it'd be interesting to see where they end up. And then obviously the big primes as well. And so I think there's, fortunately for us, a little hesitation with the innovation companies that are innovating and coming out of this early stage to want to be swallowed up by a big prime, and they want to, hopefully for us, they want to continue to test out with private equity and some of these other models that are out there.
Awesome. So, Travis, in the corporate venture capital space in national security, until recently, one of the things that was notable was how little activity there was. Lockheed had a program, Boeing tried for a while with Horizon X before outsourcing it to AEI, and then you had sort of corporate strategic acquisitions happening across all the primes. Not a lot in the space. We've seen that start to change. RTX has come out. Lockheed has more being put behind their corporate program. Booz last year had a pretty big announcement that they were coming in, not in a small way, but a pretty substantial way with their own corporate venture capital program. And I think one of the things that some people asked is, well, I thought what sort of companies you're looking at?
Yeah, sure. So I thanks, Dave, for having me. I'm kind of pinch hitting here. I know you guys aren't here to see me, so I appreciate you coming. That's why I wear my Mortal Kombat socks when Dave's with me. So, I think for us, I spent the past, 4.5 years, I came to Booz Allen from private equity to help with the intentional formation of our investment thesis, gathering the stakeholders internally, call that raising from internal LPs, right? Getting everybody aligned to where we wanted to go and how we would use this tool to further the firm's, enhancement of our clients' missions. So what does that look like, right? So that looks like the combination of, we're a large systems integrator. We're most likely, I will never say never, we're most likely not going to bend metal, right? So how do we take technologies or parts of the technology stack where we get requirements conversations from our clients, make strategic minority follow-on investments to help accelerate those. So kind of in between, private equity, traditional venture capital, and a little bit of what Ben and his team do, right, which is a little more front end of the funnel. Our goal is to understand how do we take what's out there in the landscape, how does it fit the client requirements and needs that we're hearing as we interface with those clients every day, and get to kind of the pointier end of the spear, right? So what does that look like in making that happen? So we took $100 million off the balance sheet. We can't service everyone, so we really focus in 3 areas: artificial intelligence, machine learning, cybersecurity, and then what we call digital battle space. When you think of digital battle space, think autonomy, think ABMS, convergence, overmatch, whatever your favorite term is, depending on if you're an Air Force guy, Army guy like me, or Navy. So whichever one you prefer, right? And then how do we take that and then make a strategic minority investment from the lens and from the mindset of being, I don't want to say completely strategic, because I'm accountable to the CFO. I cannot lose all the money. So, how do we make probably what we consider less than venture capital returns but also accelerate the mission. And that's really what we're trying to do there, is understand how we can accelerate those technologies inside of where we have mission intimacy. And so to that end, our incentives are aligned to be strategic.
So yeah, maybe help us understand a little more how you do that, because one of the big challenges with corporate venture capital is you have venture investors who think about maximizing a financial return on the investment. You have a company where that's not really moving the needle for them.
Sure.
So how do you get that strategic alignment with the mission of the firm?
Yeah, so it's a great question. We get that question all the time, and it's pretty simple. We sit in the middle between financial and strategic, but we lean definitely more strategic. So you heard Joe say, private equity is a 4-letter word. I get that joke all the time, right? The same for traditional venture capitalists, right? Let me know how it can be helpful, which means don't call me. So we sit at that intersection of not only can you call me, we're going to assign someone who's not their sole job, but one of their primary foci is to make our portfolio companies successful. They're going to be attached at the hip with the mission owners, so they understand where to go to impact the mission, what that looks like, and candidly, I cannot get a business case or an investment case approved in front of my investment committee without that portion. So when I go to an investment committee, I have side by side someone that is a mission owner saying, I want this technology, I believe in it, and here's where we're going to use it for all of us to be successful.
Is there a level of maturity of a company that is more or less interesting to you? And when you're looking at that company, to what degree are you looking at the technology that they bring to bear and the capabilities there versus maybe the contracts they have and the pathway that offers to you as a firm?
Yeah, so that's another great question, and it's a balance, right? So not only I have the charter of not only finding a really good venture deal in an early stage seed to Series B company, but I also have to know where I'm going to go, whether it be today. So if it's a seed company, obviously it's going to be a little longer timeline. If it's a Series B company, there would be an expectation not only from the portfolio company, but from us, that we would accelerate kind of what they're already doing, right? So depending on the stage at which we invest, the timelines get longer or shorter and flex in the right way. But really what we want to do is make sure that we see not a clear line of sight, but we definitely have an idea that we're headed in the right direction, right? So kind of, if you like the Wayne Gretzky analogy, right? Depending on what stage we invest in, we might be halfway down the ice, we might be just starting from the blue line, or we might be, getting ready to put a wrister on the top shelf, depending. So,
given the approach that you're taking with the $100 million that you have, if I were thinking about this as a traditional venture capitalist, I think maybe you're deploying half of that and holding half of it back to avoid dilution and follow-on rounds. Is that how you're thinking about it as well, or is the thought push that all out and then we'll pull more money in as we need it?
Yeah, no, we are definitely thinking about it as a life cycle investor, because as a large corporate, right, when we commit to a portfolio company, we are now quote unquote married, right? It's a horrible market signal for me to come in and out of rounds, and that's just kind of poor behavior from a corporate venture capital firm, right? So being able to understand how we're going to sleeve those investments and understand what that follow-on potential, how we're looking at that, and kind of taking that patient capital approach of, hey, we're most likely not going to run out of balance sheet money anytime soon, so it's pretty easy for me to take a patient capital approach to sleeving those investments and trying to make each one of them successful.
So maybe a similar question to one I asked Joe, when you're looking at making these investments and coming in as a strategic partner, who are you seeing around the table as competitors in that strategic space? Are you seeing the traditional primes like Lockheed and Raytheon?
Yeah.
And if so, what's the relative value proposition that you give to the firms you're investing in to say you should be with Booz instead of someone else?
Yeah, so it's really interesting, right? So, I mean, for most that don't know, venture capital is traditionally a little bit more of a team sport than maybe private equity. I've done both, so I can say yes, it very much so is. So, we've co-invested with Lockheed, we've co-invested with A Horizon X, we've co-invested with RTX. We know those folks, we talk to them, we talk about, what we think are trends, where we think things are going. So for us, it's really about the focus on the portfolio company of how each of us are going to be additive to what they're trying to accomplish, right? So from a Lockheed perspective, I'm not trying to speak for them, but they may have something they're trying to develop that's probably a 10, 15, 20-year potential burn, whereas I might have client requirements today that I can go after, right? So they kind of fit all the pieces, we pour the puzzle pieces out on the kitchen table, find the corners, and then start to figure out how we all fit together.
Got it. So 2 notes that I should give to everyone. One, I used to be a university professor, and I can talk and ask questions all day and will happily do that. The second is I have physically disadvantaged myself because I have no peripheral vision on the right side, and I'm facing this way. So if you're over here and you have questions, you may need to make a sound, but I'll try and circle back around. I should be sitting on that side. I'm going to keep asking questions, but please do, if you'd like to, jump in, raise your hands. And I think, do we have mics, or are we asking people to just speak up? Okay, we have one mic in the back, so just see if you can make them run around as much as possible, too. I'm going to ask one question while you get the mics out, and then we'll start going out. So, Ben, just to come back around to you, a lot of times on panels like this, when we're talking to venture capital shops, they have a sort of set of criticisms of the government that they like to make and what the government is doing wrong. It may be kind of fun to sort of flip the script a little and to give you a chance from the perspective you've had, saying at OSC and Naval X before that, to talk a little bit about what you're seeing from the venture capital community, sort of what they're getting right, what they're getting wrong, and sort of what differentiates the more sophisticated from the less sophisticated players in the space from your perspective.
So I would say really like the comments that we're hearing on the panel go back to very similar, and I understand your customer. And what I've seen is a lot of folks will complain that we just don't understand you, you're too hard to work with. But I also went through like sales training when I was a fellow. I was at VMware, so I got to go through all their sales training. And I have that mindset that in the end, you need to understand it's not your customer's fault that you can't sell to them or you can't figure it out. So one thing, there are some things that we've done on the government side that are really great. Like Shift has their Defense Ventures Fellows Program, where you get military people into the organization and you can learn from them. Just like how I went to industry, they learned from me, I learned from them, I came back. You have Shift, and then you have a program, SkillBridge, another great one, where you have folks coming out of the military that can go as interns. Has anyone heard of that program, SkillBridge? Yeah, it's awesome. You can sponsor a defense person, and you interview, so it's not just anybody, but someone who understands the end user perspective, so you can create that persona. So if you were an investor, you have people that get it. So what I've seen, and I'm not just saying this as a veteran, but I've noticed that sometimes you can get somebody who was once one of your customers to be on your team to help you develop relationships, not just relationships, but products that make sense and help bridge that gap. So, I was at a Vet VC Summit with JP Morgan a couple years ago, and we had this conversation, what can we do to bridge it? And Jamie Dimon goes, the fact that you're here is like half of it. We had me and Jay Weisham, former head of Army Applications Lab, but we're there in the room trying to figure out having these conversations to solve this problem. So in the end, not just making a pitch to bring veterans into the loop, but a lot of times as military folks, it's very foreign. We talked a little about the cultural differences between DoD and venture, but I think on both sides we can bridge that. And I think that's a very straightforward solution, is get the right people in the room, like you said, with the expertise that have been there and can understand and help the portfolio company succeed.
So, and actually, that reminds me, I should pitch for a second that if you're interested in these innovation organizations across DoD and what they're doing, one of the things that we've started doing is exit interviews with the leaders as they go out. So Jay Weisham, who ran the Army Applications Lab, sat down with my company Acme to do an interview for a podcast we run called Accelerate Defense. If you haven't listened to it, it's a lot of fun. The most recent interview was actually with Ben, talking about his experiences at Naval X and OSC, and that actually just came out this week. So a nice chance to get sort of their perspectives on what worked, what didn't, what did they wish they knew, what would they tell other people. So encourage you to listen to that. First question to the audience.
Caw. That's my noise so that you know I'm here. So my name is Caleb Holt. I'm located here in Central Texas. The question is essentially around defense industrial base. I license a lot of technology. I'm now building companies and manufacturing capabilities in Bryan College Station. The question is around, uncrewed and autonomous systems. Specifically, we're bringing manufacturing back to the United States, but in that process, I'm finding shortages of suppliers for certain parts that I need, and so now I'm looking at acquiring other companies. So I'm just interested from a funding standpoint, when you are talking about patient capital, sometimes I have found that there are innovators and then there are manufacturers, and it's rarely that a manufacturer will innovate in a really just dramatic change, right? It's maybe incremental innovation is what you see in manufacturing. And so I don't see the connection directly where I have amazing innovators that are also manufacturing. And so I'm curious y'all's thoughts on that, because I think we need a lot of capital for defense industrial base companies that want to support, but they're not going to be a cyber-based company that's out here trying to chase the new thing.
I'll answer very quickly. Yes, down the supply chain, 100%. At least from the OSC perspective, and you'll get to see it when they print out their investment thesis. But totally tracking what you're saying, that it isn't just the real shiny objects up here. Down the supply chain is critical, and there are companies we need to invest in. And we actually talked about it, like how do we prevent the next CHIPS Act from happening, but for defense. So we are looking at down the supply stream. What do we need to drive funding towards now so that doesn't happen? So 100% from the OSC side.
Yeah, I'll just add, one of our companies, Design Technologies, so their value proposition is that they turn previously manned aircraft into unmanned. So Group 4, Group 5, long duration, 35 to 80 hours of flight time for ISR capabilities. And these are foreign-produced aircraft that we are onshoring. And so we're taking both new models right off the factory floor and then also buying up the used market of manned aircraft to convert. So it is a rare case of manufacturing meets innovation and having to keep that steady supply going, but it's very hard to keep up with the demand, and we're looking at potentially even having to acquire downstream companies to make sure that we can continue to deliver for the U.S. government.
What was the name of that company?
Design, D-Z-Y-N-E.
Yeah, I mean, I think for us, I'll take a little different approach, Dave, which is, and to answer your question, is part of the role in my mind of a good venture capitalist is not only to write you a check and help you be successful. The other part is, how do I accelerate you into that next check? How do I accelerate you into that next place where you need capital funding for infrastructure, you need capital funding for manufacturing? How do you and we as a team come together to make that happen, right? So, Joe and I haven't spent a lot of time together, but he would be one of the people that I would call if I had a portfolio company that was in the space that he had interest in, to make sure that we're talking about that early and often, so that not only he knows the portfolio company, but could also understand the capital requirements that might come with that. Because when you talk about growth stage investing, and we've all seen the statistics on growth venture rounds, they've kind of bottomed out. What does that look like? So you have those folks that have more money, the ability to fund that business into the next 5, 6, 7, 10 years. Having that ecosystem work together is kind of paramount to get kind of where you want to go as well. And there will be some other, outside funding sources, whether it be SPIC or something else, or innovation tech hubs that you can tap into.
Yeah, at the risk of violating my own rule that moderators should realize that they're moderators and not panelists, I will just add something there, which is, I love the question because I think it gets at a gap in a lot of the discussions we have around private capital, which are so focused on early stage VC and hypergrowth companies and billion-dollar valuations, and miss this whole piece in the middle about, okay, fine, you have a cool thing. How do we make it at scale? And how do we support the companies that do that? So there are, I think, a whole set of middle market private equity companies that are focused on what, from a venture perspective, is more boring investments in this sort of manufacturing supply chain space. Office of Industrial Policy has been focused on the very bottom of that pyramid. How do we get critical metals and minerals and produce those and process them in the U.S.? But companies like CM Equity, who you've probably never heard of, have spent 20 years investing in the people who make like a really good valve, or the people who do a sort of modeling for the government that no one else does. And they don't show up on these panels all the time, but they're out there, and there's sort of an incentive for them not to show up because they've got a pretty good business model, and the fewer of them there are, the less competition there is for their deals. So I think it's important to actually highlight sort of who those people are and what they're doing as well. I think the next question was over here. Nope. All the way in the back. Dave, over to you.
Okay.
Great panel, thanks. I actually had a follow-up OSC question. It's very exciting to see that office stood up.
And my question, okay, try this one. OSC question, thanks. The question is, my understanding to date is that it's there, at least in its kind of early instantiation, to kind of fund like the scale up phase. Or that's one of the mandates is like when a company's got something that's ready to scale, you stand up production, OSC can provide that kind of growth capital. The gap that I see is more the kind of prototype to production ready gap. It's a kind of the valley of death gap. And so I wonder, my question is to kind of pressure test that part of the mandate. Can OSC kind of reach a little bit earlier and help kind of power that prototype to production ready step that requires some development and is fairly capital intensive?
Yes, we could, and I think the TAP program can go there. Because right now we can go SBIR phase 2s, and if a company's already got a SBIR phase 3 but needs more, we can do concurrent phase 2s on a phase 3. Also, right now, OSC is fairly young. We're using SBIR money. However, assuming we get what we wanted in our budget, the organization will also have 6.4 R&D money that they can use for that acceleration. And so, yes, I would say the TAP is going after that area. Not just lab to product, but also product to product in that area, because that is a huge problem. So, TAP.
Great, thank you. Yeah, and this is maybe his insight from our CFO, that like he sort of told me this, like, hey, once we're ready to just scale, that's kind of the easy part. You can get that capital from a lot of places, and so that's maybe not as unique at that phase.
Well, my comment, this is Ben's opinion, usually the challenges I've seen is we've brought TAP in and building through it. The challenge is getting the defense customer to say, I want it. There's so many great companies that were ready, and it's like, okay, do you want this? Defense, whoever your lead is, okay, put in money behind it. You just want more, right? Then we can come in and start bringing more in. But usually that's the biggest challenge I've seen, is getting the commitment from the service to say we want it. However, what I have personally experienced is when I've gone and talked to, say, resource sponsors that, wait, I really like this, it's just a little bit lower on the list, I've only got this much money, and I say, well, I said, I'm here from OSD and I'm trying to give you money. Like, say you want it, and you put skin in the game, then I can put mine in, and that creates a much more compelling argument or business case, de-risk it for private investment to say, no, we really want this. And if behind the scenes, another thing I haven't talked about yet, is we have liaison officers with the services that are doing all of the behind the scenes work with program officers, resource sponsors, fleets, so we can go to those investors and go, it's not just service money plus OSD money to get this there. Here are all the people in the room. We got a program office identified. This is he's here. This is the resource sponsor. He knows. He's nodding up and down. And within the law, I can't promise you everything, but here's all the stuff we're going behind you. So if you invest in this, it's much better than what would be otherwise, which is just kind of hoping it gets bombed. So those are the type of things we're working, and it's been going. But what I will say is we've had great support from leadership, which is number one. Great leadership support, and what we've tried to do. Building the team was hard, but a joy because I actually had the support to do it.
Thank you.
Other questions from the audience? Got one up front, and I think you've been waiting, so let's go to...
Thank you. Jason Devitt here from Compound I. So I'm interested, and this is not to harp on about OSC, I'm interested in how the program that OSC is developing overlaps or contrasts with TAC-FI, STRAT-FI programs out of AFWorks or the new Catalyst program from the Army. And then follow on from that, these are all matching fund programs. Army, or rather, and DoD customer R&D money plus private capital. Is that the strategically optimal way to go, or do we need to find a way, does Congress need to mandate the ability for the DoD or for a particular Army customer to just be able to write a bigger check straight off to a company that's developing an interesting technology?
I think that's, I'll do this really quick lead in. All right, so I literally, before I came on here, reposted to my LinkedIn section 925 of the NDAA for the non-traditional innovation fielding enterprise. Take a look, it's really good. So Congress has realized this. And so what they've proposed, and it's made it through conference, it's in the bill, is $1 billion DIU with fielding activities in each service to do what you're saying. To say, here's the 10th, what we want to get after, and here's money with the firepower, day one of OSD, an idea without resources is hallucination. You got resources, you got people, you got authorities, and $1 billion, and to go out and cut those checks. The next, so please read that. I redid it on my LinkedIn so you can see it. Just go in, it's the last post I did. Awesome legislation. I think it's fantastic. And then the next part, at least from the OSC perspective, is day one, we're working with the AFIT folks. We're working with, we all came from this space. So the team is made up of MIU, DIU, AAL, Naval X, OSC, former DARPA people. I mean, we got coming from private equity, coming from venture. So all these, we're connecting an integrated value chain. So we're looking at, and, hey, what did AFIT, oh, this is an AFIT company. What can we do here? Oh, this one's a cyber company with Navy. How can we connect the dots? And it's really hard. But OSC has the team to do it. So the answer is, it's the connecting the dots and doing that hard work, not doing the usual thing of this is my lane, I stay in it. What we're taught to do, stay in your lane and don't rock the boat, and this is my rice bowl. It's crossing the streams, and I'm seeing very, very excited about what I've seen within the department. So kind of two answers. That's me.
Awesome. I'd like to agree with that as well, and then I think there's an opportunity that's from the private equity side. Again, this is self-serving, but instead of individual cooperative research agreements with the specific companies, why not do it with a firm and do all of their holdings? And so there's an opportunity, I think, there where private equity will invest alongside government, and we're both de-risking the risk to each of our operations. And so I would love to see CRADAs go at the private equity level or at the PE, I don't know if it would quite work so well, but certainly at the private equity, the holding company level, to be able to involve all of these autonomous system technologies, these advancements all in one place.
But yeah, it's a great point, Joe. And one of the things that some of you may have seen that DIU and the National Security Innovation Network and the Army Applications Lab and others have started trying to do is figure out how do we just communicate better with private investors around what we're seeing with the companies that we're investing in the form of these non-dilutive R&D grants. Who's on a path that seems promising, who's really exciting. So they've started doing sort of feature showcases with their companies. And so if you're in the space and you have those contracts, I would encourage you to try and get featured in those showcases. If you're an investor, I would encourage you to make time to actually listen to them, because the government's trying to figure out how do I convey useful information to make it less opaque between I gave this company $1 million to do something interesting and find whatever, and I would like this company to scale and be really successful. And I may not be able to say that to you in so many words, but I can certainly tell you what I find exciting about them and the work that we've done to date. So that's getting better. Question in front?
Yeah.
So I'm curious, it's a little bit of a policy question, a little bit of a cross-money question, protecting the industrial base. So I know we've got some former Boston Dynamics people in the room. I'm not one of them. But here we had a company where massive investment was made, out of defense, like really created novel, capability, which thank goodness we have like Aptronic, catching up on legged robots, and still domestic. How do we protect these innovative companies from being sold overseas and being denied access to DoD? Because when we saw Google acquire, BDI, all of a sudden faucets turned off. Like no more work going to DoD over that, even though that really built that organization.
I'll do very quickly. As part of our investment thesis, it's one of the things that we're looking at is what are companies that we need to invest in and get on their cap table now so it's not taken by foreign investment. We're looking at it, and it's part of our thesis.
Yeah, I'd say from our perspective, it's very much on the due diligence side of trying to help founders navigate the waters of where they're taking investment from and where they might think they're taking investment from, but it actually might be something different, right? So I think there's a little bit of onus on the partnership between the VC or the CVC and the founder to kind of understand what the roadmap looks like and where you want to go to make sure that you can navigate those landmines, right? So.
I like to be a contrarian, so I guess the thing that I would say about that is I think sometimes we're too focused on, for example, how do we hold information tight versus moving fast, and how do we keep things domestic instead of accessing the best technology? And 30 years ago, like, those things were probably not in conflict because we had the best companies and we had the best technology. There's an awful lot of spaces right now where that's not true. And I'm not sure that the bigger problem isn't that we're not tapping into innovative Korean companies and Japanese companies and European companies where they're part of what should be an allied defense industrial base, and we're so focused on only building domestic. I think there's a balance there that we need to get better at striking. And also, and Joe sort of pointed out to this, I think we're seeing it with companies like Anduril, who've got a lot of traction in Australia. It's not just about the technology, it's about the policies and procedures for working with innovative companies. I think there's something to be learned from countries overseas that are actually doing it better than we're doing it here about how do you design solicitations and programs to pull those companies in.
And to build on that, I don't think we really have the policy in place to protect U.S.-focused only investment. So we can do our best innovation overseas. We can immediately test on the active runways in Singapore, but it takes me a month and a half to get permission to go to a range in the deserts of Idaho, much less turn on any active EW systems. So that's a problem, and the real-life use cases that we're testing overseas with overseas partners who actually have an FAA-level approval to do these sorts of technologies, that doesn't exist here, so we have to partner over there. We can do it not cheaper, but at least quicker cheaper in the sense that it's faster before we bring it back to the innovation back home.
Yeah. Well, and you may have seen in Ukraine over the last year, we've seen multiple accelerators stand up that are meant to pull in foreign technology to test on the battlefield there because they can. And on the sort of opposite side of that spectrum, if you look at Southcom, which is like the forgotten combatant command because all the attention is elsewhere, what they can bring to bear is a permissive environment among partner countries in the AOR for doing test and evaluation in the field in a way that's often substantially easier than doing it in the US. And so you're starting to see a lot of interesting companies get pulled down by General Richardson into the Southcom AOR, which is, I think, also worth people looking at. We are 1 minute from the end here, so let me just give a chance to the panelists for any final words for the group, one by one. Ben?
No, thank you for having me.
Awesome. Joe?
Likewise, thank you. Real honor.
Yeah, same. Looking forward to partnering with everybody in the room. So
Awesome.
thanks.
Well, thank you all for making time today. I know it's tough to be right before lunch. Big round of applause for the panelists.
Thank you, guys. Pretty good conversation. I need to follow up with a few of you. Thanks, Dave. Appreciate it. So before you guys run out to lunch, we just wanted to have some closing remarks from Dr. Sadowski, and then I'll have some admin stuff after that. So give me about 5 minutes here and let him close it out. Hear from the Army's chief roboticist. Last chance.
So, hey, I appreciate the opportunity to go ahead. I know you all want to talk up to the folks with money up here, as opposed to us here in the poor Army. Where are my folks from my capability development integration directorates, my CDIDs? Are they still here? Folks, look at these people who have their hands up, okay? When it comes to requirements, trying to figure out what people are all doing, talk to the folks from these integration directorates. I can help be the marriage broker if you have a unique technology. The other piece I wanted to focus on was General Rainey was talking about this waterfall of persistent experimentation that we're going to do. There's a role for the Army labs. There's a role for joint partners. There's a role for the training centers. There's a role for what we're going to actually put inside these formations. And what did he say? We're going to start small, go fast, and hopefully succeed fast, not fail early. And what that's going to mean is that you're going to please be on the lookout for these opportunities. They're going to come fast. This was supposed to be focused on the light formations, and I appreciate all the folks who are coming in to come down here and see the challenge in the light formations. But understand that for some of these systems, we actually have standards. I will put a plug in to go to rawsmilitary.org, only because a lot of the stuff, standards, tutorials, information is there. You have to be a U.S. citizen, and they will vet you to kind of look at, to give you an idea of kind of some of the problem spaces and what's already been specified out there to make it a lot easier for you all to integrate within the DoD space. The other piece is pay attention to what AAL does. AAL manages a lot of SIBRs for the Army. But you also got to pay attention to the SIBRs that the PEOs are putting out there, because a lot of times those are focused on gaps they have for emerging technology. So again, I just want to make sure we welcomed everybody out here to understand that this was just looking at the light. The heavy's a much bigger challenge. And for a lot of the things, we may be looking for software enabling capabilities to add on to existing systems to make them more effective. So it's not just about hardware solutions in this space, it's also about software solutions. And other than that, who's got the admin remarks after me? rossmilitary.org. Yeah, ROS, like robotic operating system, military.org. Sometimes you'll hear us call it ROSM, because it's like one of those few places that I get to play with Amazon and Microsoft and kind of try to tweak them when it comes to robotic operating system, particularly 2.0, to help meet the military need, but also meet y'all's needs as well. All right, appreciate y'all coming out here. Where's Mr. Admin? All right.
Admin.
No, I appreciate it, sir.
I don't know about that, Bob. But so, a couple of quick things. The Capital Factory wants us to remind you again they're hosting this Fed Supernova. A pretty good innovation event bringing together DoD and federal partners, as I mentioned. So that's August 22nd through 24th, if you want to look that up. Probably the best event for DoD innovation and a good mix that we see here. So I just want to remind you guys that lunch is open and everywhere. Sadly, we didn't supply it. So, and then we start again at 2 o'clock like we did yesterday upstairs in some of the other rooms. So just a couple of quick thank yous here. Certainly, Army Futures Command has allowed us at AAL to put all this together. I was supported by Mike and Ari and Katie and Scott and Elvis and Cam and Heidi and Christina for a pretty good run of show, as they say. And then Niati too, helping us with Capital Factory and the team and support staff, including Vivian and all the audio folks. So I want to thank all the panelists and speakers, all the AFC comms guys that are running this upstairs on the 8th floor, and then the SMEs and all you industry partners as well. Thanks for coming. I think you guys have our info. Let me know if you need anything. See you later. Sure, thank you. Well, I don't know. I don't know if it was any good, but I hope